Have you ever stood at the edge of something immense, something that once divided worlds, shaped history, and whispered secrets of a planet in motion? Picture a cliff so vast it once marked the border between entire continents, a natural wall that guided the flow of life, cultures, and time itself. Now imagine that same cliff, not as a feature on a modern map, but as a ghost of Earth's deep past, eroded, submerged, or simply forgotten, yet still echoing with the stories of everything that unfolded along its edge. These aren't just rocks, they're the keepers of our planet's most dramatic transformations. They witnessed the slow dance of continents, the rise and fall of ancient ecosystems, and the footsteps of early humans who made their homes in the shadow of these colossal boundaries. In this video, we're setting out on a journey to rediscover 27 of these forgotten cliffs' natural borders that once separated continents and defined the shape of the world as it used to be. From the submerged edges of Pangea to the weathered remains of supercontinents like Rodinia and Gondwana, each of these formations holds clues to Earth's ever-changing identity. We'll explore how tectonic forces, climate shifts, and the passage of millions of years have erased these borders from common memory, yet left behind traces that geologists, historians, and adventurers are only now beginning to piece together. This is more than a tour of remote landscapes. It's an invitation to see the planet through a deeper, more dynamic lens, one where borders are temporary, and the ground beneath our feet tells a story of perpetual motion. You'll travel from the frosty peaks of Scandinavia, where cliffs once divided ancient landmasses, to the sun-baked escarpments of North Africa that guarded the meeting point of continents. You'll dive below ocean surfaces to explore submerged boundaries that guided human migration and shaped evolution, and you'll climb high into mountain ranges that were once the front lines of continental collisions. Each of these 27 cliffs has a unique tale of civilizations that rose and fell along their ridges, of species that evolved in isolation on one side or the other, and of the raw geological forces that continue to reshape our world. So come with us not just as a viewer but as an explorer. Let's uncover these hidden lines together and listen to the stories they've been waiting to tell. To truly grasp the significance of these vanished borders, we need to rewind the clock and look at the immense, slow-motion forces that build and break continents. The story begins deep beneath our feet with the restless movement of tectonic plates. Picture the Earth's crust not as a solid, unbroken shell, but as a gigantic jigsaw puzzle with each piece constantly, imperceptibly shifting. These massive slabs of rock float on the hotter, softer layer beneath them, drifting apart, colliding, or grinding past one another over millions of years. It's at the edges of these plates where the most dramatic geology happens, when two continents crunch together in a colossal slow-motion crash. The force is so unimaginable that it crumples the land, thrusting up vast mountain ranges with sheer, towering cliffs marking the suture line between once separate worlds. Conversely, when plates pull apart, they create massive rift valleys with steep, newly formed escarpments on either side, the birth scars of a future ocean. But tectonic force is only the initial artist. Once these raw, dramatic borders are raised up, other processes immediately begin to sculpt and eventually obscure them. Erosion, driven by wind, rain, ice, and rivers, acts like nature's sandpaper, relentlessly wearing down even the mightiest cliffs over geological time. A mountain range that once stood as a sharp, impenetrable wall between continents can, across eons, be ground down into gentle rolling hills, its history hidden in the rounded landscape. Meanwhile, sea levels are in a constant state of flux, largely tied to the amount of water locked away in vast polar ice caps during global ice ages. When sea levels are low, as they were during the last glacial maximum, continental shelves are exposed, creating new land bridges and making coastal cliffs into inland hills. When the ice melts and the seas rise, these same borders are drowned, submerged beneath the waves, becoming hidden secrets of the seafloor. This combination of titanic construction and gradual destruction means that the continental borders of the deep past are rarely the coastlines of today. They are ghosts in the landscape, their stories written in the folded layers of rock, the unusual distribution of fossils, and the unique cultures that developed in their shadow. Understanding this dynamic interplay is the key that unlocks the history hidden in plain sight, setting the stage for us to explore these 27 forgotten sentinels of Earth's ever-changing face. Rising like a frozen backbone between Norway and Sweden, the Scandinavian mountains, or Scans, stand as a silent monument to a time when continents wore entirely different shapes. This majestic range was once the dramatic edge of the ancient continent of Baltica, a colossal cliff face staring across a vanished ocean toward the landmass of Laurentia, which would one day form the core of North America. This wasn't just a geological boundary, it was a continental coastline over 450 million years old, a testament to the assembly of the supercontinent Rodinia. Imagine the sheer scale of these primordial cliffs, likely far more jagged and imposing than the rounded peaks we see today, serving as an impassable wall between two entirely separate worlds. The legacy of this ancient divide is etched into the very rock itself. Geologists studying the Scans find fascinating clues like fragments of oceanic crust and mantle rock known as ophiolites, which were literally scraped off the seafloor and plastered onto the continent during that ancient collision. It's as if the mountains are preserving the evidence of their own violent birth. The mineral deposits tell a similar story, with valuable ores like iron and copper concentrated along these ancient fault lines, a direct result of the immense pressures and hydrothermal fluids that circulated during the continental merger. These resources weren't just hidden for eons, they became the economic lifeblood for the human cultures that eventually settled in the shadow of these giants. And those human stories are deeply intertwined with the geology. For early Scandinavian settlers, the imposing barrier of the Scans wasn't just a physical challenge, it shaped their entire worldview. The mountains became a natural border, influencing settlement patterns and creating distinct cultural regions. This dramatic landscape is deeply woven into the fabric of Norse mythology. The gods themselves were said to reside in rocky strongholds, and the treacherous, high-altitude terrain was often described in sagas as the dwelling place of giants and other supernatural beings, a physical manifestation of the unknown and the dangerous. For the Vikings who later set sail from these fjord-carved coasts, the skills of navigation and resilience required to survive in such a harsh, mountainous environment undoubtedly contributed to their famed seafaring prowess. They learned to read brutal landscapes before they ever learned to read the stars. The cliffs we see now are merely a softened echo of their former glory. Millions of years of relentless erosion, dramatically accelerated by the grinding power of massive Ice Age glaciers, have planed down the peaks and carved the deep, U-shaped valleys and iconic fjords that define the region today. The ice acted like a colossal sheet of sandpaper, scouring away the sharp edges and revealing the ancient, folded layers of rock beneath. This very process of destruction, however, is what allows scientists to so clearly see the evidence of construction. The glaciers exposed the bones of the mountain range, giving us a cross-section view into one of Earth's oldest sutures. As we leave these northern sentinels, we turn our gaze from a border born of collision to one defined by a slow, continental rupture, journeying next to the sun-baked cliffs that once guarded the gateway between Africa and Eurasia. Leaving the frost-carved peaks of Scandinavia behind, we journey south to where the sun beats down on a landscape of equal geological drama. The northern escarpment of the Atlas Mountains in Morocco and Algeria presents a breathtaking sight, a formidable wall of rock that rises with startling abruptness from the coastal plains. This isn't just a scenic wonder, it's a fossilized border, the ghost of a colossal continental showdown. These cliffs are the enduring scar of a titanic collision, marking where the northward moving African plate once slammed into the underbelly of the Eurasian plate. This slow-motion impact, which began tens of millions of years ago, didn't just raise mountains. It was a primary architect in the very formation of the Mediterranean sea basin, squeezing and buckling the Earth's crust to create a new geography. This immense natural barrier didn't go unnoticed by the ancient world. For emerging civilizations, these cliffs were the ultimate strategic high ground. The Carthaginians, a formidable maritime power, recognized their defensive potential, establishing outposts that watched over their territories. Later, the Romans, masters of empire building, saw the same value. They constructed a network of fortifications and watchtowers along these ridges, using the escarpment as a natural rampart to control movement and defend their North African provinces from desert tribes. The ruins of these settlements, now weathered and silent, still cling to the mountain slopes, their stones telling a story of how geology directly influenced the march of human history and the drawing of ancient political borders. Beyond its role in human conflict, this ancient continental boundary created a unique sanctuary for life itself. The Atlas Mountains act as a colossal sponge, wringing moisture from the Atlantic winds and creating a cooler, wetter climate on their northern slopes. This environment became a biological crossroads, a place where species from Africa and Europe could meet and mingle in isolation. Over millennia, this led to an explosion of endemic species found nowhere else on Earth. The majestic Atlas cedar tree, for instance, and the endangered Barbary macaque are living relics of this unique convergence. The escarpment itself creates microclimates. A short journey from the arid foothills to the cooler, forested peaks is like traveling between continents, a direct echo of its past as a transitional zone between two worlds. Finding the original, pristine cliff face today requires a bit of geological detective work. Millennia of erosion have softened its profile, while human hands have terraced its slopes for agriculture for centuries, further blending the sharp edges of the natural border. Yet its story is far from lost. Modern technology allows us to peer through these surface changes. Satellite imagery and LiDAR surveys reveal the hidden lines of the original fault systems beneath the vegetation. Core samples drilled from the rock layers tell a clear story, revealing sequences of marine sediments that were violently uplifted and folded, confirming this was once the dramatic coastline of a closing ocean. This ongoing research continues to piece together the magnificent puzzle of this forgotten border, a cliff that stood as a silent sentinel between continents. Our next destination takes us to a boundary of an entirely different nature, from the meeting point of Africa and Eurasia to a cliff that witnessed the great divorce of South America and Antarctica. Now we travel from the sun-drenched ramparts of North Africa to the rugged, high-altitude landscapes of western Argentina, where the Andes Mountains tell a story of a much colder, more ancient separation. The Precordillera region is a geological wonder, a series of parallel mountain ranges and valleys that run like wrinkles across the land. But long before these cliffs framed the horizon, They served as a monumental border wall between two continents that are now worlds apart, South America and Antarctica. This dramatic landscape is a direct result of the breakup of the supercontinent Gondwana, a slow, tectonic divorce that began over 180 million years ago. As these colossal landmasses started to drift away from each other, the crust between them stretched, thinned, and eventually ruptured. The Precordilleras cliffs are the fossilized remains of that rupture zone, the crumbling edge of the continent left behind as Antarctica began its long, lonely journey toward the South Pole. The evidence for this lost coastline is written in the very stone of the mountains. The cliffs are composed of layer upon layer of sedimentary rock, and within those layers, scientists find a treasure trove of marine fossils. It's almost surreal to stand in the dry, thin air of the high Andes and hold the fossilized remains of ancient sea creatures in your hand. We're talking about trilobites, brachiopods, and crinoids, clear indicators that these towering peaks were once the muddy bottom of a shallow sea. This area was a dynamic continental margin, where the oceanic plate was gradually sliding beneath the South American plate in a process called subduction. This collision not only built the initial mountains but also preserved a perfect snapshot of that ancient marine environment, lifting it thousands of meters into the sky for us to discover. This imposing terrain didn't just influence geology, it shaped the flow of life and human history for millennia. For animals and plants, the rising cliffs created a formidable barrier that isolated species and guided the course of evolution on the continent. For humans, the Precordillera presented both a challenge and a sanctuary. Indigenous cultures like the Diaguita, who thrived in these valleys before the Inca expansion, were master adapters. They learned to navigate the steep slopes and arid climate, and they recognized the strategic value of these natural fortifications. They built their settlements, known as pucarás, on high, easily defensible ridges within the Precordillera, using the cliffs as a shield against invaders. The ruins of these stone structures still dot the landscape, a testament to how human ingenuity intertwined with this ancient geology for survival. The face of the Precordillera today is markedly different from its primordial past. Modern pressures have left their mark, with large-scale mining operations carving into the mountainsides in search of copper and other minerals, while growing cities and vineyards spread across the valleys. This development, while vital for the local economy, inevitably obscures the original cliff lines and alters the historic landscape. Yet, the memory of this once prominent boundary is far from lost. Geologists continue to piece together its story through meticulous fieldwork, using tools like seismic imaging and satellite data to map the hidden fault systems and reconstruct the original continental edge. Their work ensures that even as the surface changes, the profound history of this place, as a sentinel watching over the separation of continents, is preserved for future generations to understand and appreciate. Our journey now takes us to the wild and windswept coasts of Scotland and the remote shores of eastern Greenland, where the ghosts of a truly ancient border still haunt the landscape. This is the realm of the Caledonian mountain belt, a chain of cliffs and highlands that tells a story of one of Earth's most monumental continental collisions. Over 400 million years ago, during the Paleozoic era, the ancient continents of Laurentia, the core of modern North America, and Baltica, the heart of Scandinavia, were on an inescapable collision course. The result was a cataclysm in slow motion, a tectonic crunch that threw up a mountain range of Himalayan proportions. Imagine a continuous, towering wall of rock, a formidable natural barrier that stretched unbroken from what is now Scotland all the way across the North Atlantic to Greenland. This was not a gentle border, it was a suture line, a colossal scar on the planet where two separate worlds were literally fused into one. the dramatic landscapes we see today are merely the eroded roots of those once mighty peaks. Millions of years of relentless wind, rain, and the immense grinding power of glaciers have planed these giants down, sculpting them into the iconic scenery we recognize now. In Scotland, the violence of that ancient collision is softened into the beautiful, rolling highlands and the deep, serene lochs. In Norway and Greenland, the same forces carved the breathtaking, steep-walled fjords that slice into the coastline. But if the original height is gone, the story is not. The bedrock itself is the history book. Geologists can walk up to these cliffs and read the evidence clear as day: folded and metamorphosed rocks that were once deep underground, fragments of ancient ocean floor caught in the collision, and the telltale signs of gigantic thrust faults where entire slabs of continent were shoved up and over one another. It's a stunning open-air museum of a mountain-building event preserved in stone. This ancient border did more than just shape rock. It profoundly influenced the course of human history long after the mountains had worn down. The fjords and sea lochs carved into this old mountain range created perfect natural harbors, which became the cradle of Norse seafaring culture. The Vikings didn't just happen to live here. Their entire way of life was dictated by this geology. Their iconic longships were designed to navigate these deep, protected waterways, and the cliffs provided landmarks for their daring voyages across the North Atlantic. The Norse sagas are filled with references to these dramatic landscapes, often imbuing them with mystical significance home to gods, giants, and spirits. Archaeological finds, from Viking settlements in Greenland to stone brocks and forts in Scotland, show how human communities clustered and thrived along this ancient continental edge, using it for defense, navigation, and inspiration. Today, this forgotten boundary is revealing new secrets thanks to a modern force, climate change. As the planet warms and glaciers retreat at an accelerating rate, they are acting like a curtain being pulled back on a stage. In both Scotland and Greenland, ice melt is exposing patches of ground that have been hidden for thousands of years. For geologists, this is a golden opportunity. They are finding new rock exposures, previously unknown fossil sites, and fresh evidence of how the glaciers themselves sculpted the land. Each summer's melt offers a new batch of clues, helping scientists refine their understanding of not only the ancient Caledonian collision, but also the more recent ice ages that shaped the North Atlantic world. It's a poignant reminder that the Earth's story is never fully written. Even its most ancient chapters are still being edited and understood. From this northern realm of ice and rock, we now venture to a boundary of an entirely different character, not defined by collision but by division, a cliff that once marked the profound biological split between Asia and Australia. From the icy fjords of the north, we now sail into the warm, tropical waters of the Indonesian archipelago, a place where the very concept of a continental border takes on a strange and invisible form. Here, the boundary isn't a single, towering cliff face you can stand before, but a deep, hidden line drawn through the ocean itself, a biological Great Wall discovered not by a geologist with a hammer, but by a naturalist chasing butterflies. This is the Wallace Line, named for the brilliant and often overshadowed Alfred Russel Wallace, who in the 1850s noticed something utterly perplexing. On the islands of Bali and Borneo, the wildlife was classically Asian. You'd find tigers, rhinos, and monkeys. But just a short boat ride away, on the islands of Lombok and Sulawesi, the forests were filled with the sounds of a different world: marsupials, cockatoos, and birds of paradise, creatures straight out of Australia. He realized he was standing on a hidden frontier, an ancient dividing line between entire biological universes. This invisible wall has a very solid geological foundation. The islands west of the line, like Bali and Java, sit on the shallow continental shelf of Sunderland, an extension of Asia. Conversely, the islands to the east, like New Guinea and Aru, are perched on the Sahel Shelf connected to Australia. But between them lies a deep ocean trench, in some places over 7,000 meters deep, known as the Wallace Line. This isn't just a ditch in the seafloor, it's a profound and enduring barrier. During the ice ages, when sea levels dropped, land bridges emerged connecting Asia to its shelf islands and Australia to its own. But that deep trench remained a permanent, watery moat, far too vast for most land animals to cross. For millions of years, it acted as an impassable barrier, allowing evolution to march to entirely different drumbeats on either side, creating the stark biological contrast that so amazed Wallace. The most fascinating places are the islands that are caught directly in the middle of this evolutionary tug of war, with Sulawesi being the prime example. This island is a spectacular geological oddity, a shape-shifting puzzle of a landmass formed from fragments of different continents that have been smashed together over eons. Because of this chaotic history, its wildlife is a breathtaking mix. You might find Asian macaques scrambling through trees alongside a babirusa, a bizarre pig deer found nowhere else, while Australian-inspired marsupial cuscuses cling to the branches overhead. It's a living laboratory of hybrid evolution, a place where the rules of biogeography were rewritten, and it offers scientists an unparalleled window into how species adapt and diversify when continents provide them with a blank slate and a strange new neighbor. This deep water boundary also played a crucial yet daunting role in the story of human migration. For early hominins like Homo erectus, who had spread across Southeast Asia over 1 million years ago, the Wallace Line presented a formidable challenge. They could walk to Bali on exposed land, but to reach Lombok and the islands beyond required a significant leap, a sea crossing. This line marks one of the first major oceanic barriers our ancient relatives ever faced. The fact that tools and fossils are found east of the line tells a story of incredible ingenuity and courage, suggesting that even with the most primitive of watercraft, these early humans were willing to venture into the unknown, forever altering the demographic map of the planet. The landscape of Indonesia is anything but static. It is one of the most volcanically and tectonically active regions on Earth. Eruptions have built new islands and buried old coastlines, while constant seismic activity steadily shifts the land. This relentless geological churn has modified the original cliff of the deep trench, blurring its edges and creating a complex zone of transition that scientists now call Wallacea. Yet, despite this constant reshaping, the fundamental principle discovered by Wallace holds strong. The deep water barrier maintained its power for so long that its imprint is permanently etched into the DNA of the region's flora and fauna. Today, the Wallace Line remains one of the most important concepts in biogeography, a classic example of how the deep, slow forces of plate tectonics don't just build mountains, they build entire worlds, separate and unique, divided by an ocean abyss. This understanding of a border defined by life itself prepares us to examine a cliff of a much more tangible and colossal nature, one that formed from the epic construction of the last great supercontinent, Pangea. Leaving the biological dividing line of Indonesia behind, we now travel to the heart of North America, to a landscape that tells a story of an even more ancient and powerful union. Nestled in the states of Arkansas and Oklahoma, the Wachita Mountains present a scene of gentle, forested ridges that seem to roll on forever. To the casual observer, it's a tranquil, almost unremarkable vista. But this is one of geology's greatest deceptions. These worn-down hills are the deeply eroded roots of a mountain range that was once as grand and imposing as the modern Himalayas. The eastern escarpment of the Wachitas was nothing less than the front line in a continental collision of epic proportions, a colossal cliff face that marked the boundary where the ancient corner of what is now Africa slammed into the North American plate during the violent assembly of the supercontinent Pangea over 300 million years ago. The immense forces of that collision did more than just push rock skyward. They fundamentally altered the chemistry and economy of the region for eons to come. As the continents crunched together, the seafloor that once separated them was squeezed, folded, and thrust upward. This incredible pressure cooked the organic, rich sediments that had accumulated on that seafloor, slowly transforming them over millions of years into the vast reservoirs of fossil fuels we know today. The formation just to the north of the mountains, the Arkoma Basin, is a direct result of this tectonic struggle. This geological bowl, created by the downward flexing of the crust under the weight of the new mountains, became a perfect trap for natural gas and oil. So the very same forces that built a towering cliff also forged an energy treasure chest, linking the region's deep past to its modern identity. Long before this modern resource extraction began, these ancient slopes held a different kind of value for the people who called them home. For Native American tribes like the Caddo Nation, the Wachitas were not a forgotten border but a thriving homeland. The softer, weathered sandstones of the escarpment provided ideal locations for shelter, with natural rock overhangs and caves offering protection from the elements. The mountains were a source of vital resources. Novaculite, an exceptionally hard and fine-grained stone, was quarried from these hills and meticulously crafted into razor-sharp tools, knives, and ceremonial objects that were traded across vast distances. For the Caddo, the geology was interwoven with daily life and spirituality, embedding a rich cultural significance into the very bedrock of this ancient continental margin. Finding the ghost of that original, monumental cliff requires looking past the serene, green surface. Centuries of erosion have done their work, softening jagged peaks into rounded hills and burying the most dramatic evidence under soil and vegetation. But the truth is still there, hidden in plain sight. Modern geologists use the tools of their trade like sonic time machines. They deploy seismic surveys, sending shockwaves deep into the ground and reading the echoes that return to map the hidden architecture of the crust. These data reveal the incredible truth: the rock layers here are not lying flat. They are bent and folded into gigantic, underground waves, with some thrust faults showing that layers of rock were pushed horizontally for dozens of miles. This subterranean violence paints a vivid picture of the titanic forces that once raised a mighty border where now only quiet forests stand. Our journey now takes us from this North American collision zone to a cliff of an entirely different character, one that was not forged in a collision, but born from a dramatic separation. The western edge of an ancient island continent that would one day crash into Asia to form the highest mountains on Earth. Sailing westward from the fragmented islands of Indonesia, we arrive at a landmass that was once a continent unto itself, a colossal island adrift in the ancient Tethys Ocean. This is the Indian subcontinent, and along its western flank runs one of the most dramatic and biodiverse escarpments on the planet, the Western Ghats. These are not mountains in the typical sense of a crumpled, continental collision zone. They are something far older and more significant. The Ghats are a relic coastline, a towering cliff face that for millions of years defined the entire western edge of the drifting Indian plate. Before its fateful collision with Asia, India was a lone voyager, and the Western Ghats were its dramatic prow, cutting through the ocean waves on a 60-million-year journey northward. The sheer drop of these cliffs toward the Arabian Sea is the last remaining vestige of that incredible solo voyage, a fossilized continental margin that time and tectonics have miraculously preserved. The story of these cliffs begins with the breakup of the supercontinent Gondwana. As India tore itself away from Madagascar and then Antarctica, it left behind a raw, rift valley edge that would eventually be sculpted by erosion into the steep escarpment we see today. The rock layers here are a library of Earth's history, with some formations dating back over 2 billion years. But the most telling feature is the Deccan Traps, vast, layered plateaus of volcanic basalt that erupted catastrophically as India passed over a hotspot in the crust. This series of immense volcanic events, among the largest in Earth's history, spewed enough lava to bury entire landscapes and fundamentally altered the planet's climate. These basalt layers form the very foundation of the Western Ghats, creating a hard, resistant caprock that has allowed the escarpment to maintain its dramatic profile against the relentless forces of erosion. This unique geological history has created a living laboratory for evolution. The Western Ghats act as a giant barrier, intercepting the moisture-laden monsoon winds blowing in from the Arabian Sea. As the air is forced to rise up the steep slopes, it cools, condenses, and unleashes torrential rains, creating a stark rain shadow on the leeward side. This phenomenon has given rise to a breathtaking array of ecosystems, from lush tropical rainforests on the windward slopes to drier deciduous forests on the plateau. This isolation and climatic variation have made the Ghats a cradle of endemism, a place where species evolved in a world of their own. A staggering number of the plants, amphibians, reptiles, and fish found here exist nowhere else on Earth, including iconic species like the majestic lion-tailed macaque and the elusive Nilgiri tar, a sure-footed mountain ungulate that clings to the steepest cliffs. Human history is deeply entwined with this ancient geography. For millennia, the formidable wall of the Ghats dictated the routes of migration and trade. Inland kingdoms were protected by this natural rampart, while maritime traders plying the ancient spice route knew to sail south until they sighted these familiar peaks, a sign that they were approaching the rich ports of the Malabar coast. The spices that grew in the Ghats shaded forests, black pepper, cardamom, and cinnamon, were as valuable as gold and drew empires from across the globe. The cliffs also hold profound spiritual significance. Their high peaks, known as shola, are considered abodes of gods and are dotted with ancient temples, while countless rivers that birth in these misty highlands are revered as goddesses in Hindu mythology, their sources sacred pilgrimage sites. Today, this unparalleled natural and cultural heritage faces immense pressure. Explosive population growth, expanding coffee and tea plantations, and rampant deforestation for agriculture have fragmented the ancient forests and threatened the stability of the slopes. The very monsoons that give the region life now also bring devastating landslides to areas where the land has been cleared. Recognizing this crisis, conservationists and the Indian government have fought to protect what remains. Large sections are now designated as an UNESCO World Heritage Site for their extraordinary biological value, and numerous wildlife sanctuaries and national parks work to create corridors for endangered species. The story of the Western Ghats is an urgent reminder that these forgotten cliffs are not just relics of the deep past. They are vibrant, living systems whose preservation is critical for countless species, including our own. This journey along the edge of a lost continent now leads us to another monumental rift, where a similar story of separation unfolded on the other side of the world. Stretching for over 1,500 kilometers along the southeastern coast of Brazil, the Serra do Mar is not merely a mountain range. It is a monumental testament to one of the most significant geological events in our planet's history. This breathtaking escarpment, with its sheer green-clad walls plunging directly into the Atlantic Ocean, is the preserved edge of a continental divorce that reshaped the world. Over 150 million years ago, during the Jurassic period, the supercontinent Gondwana began to rupture. The landmasses we now know as South America and Africa, once locked in a continental embrace, started to pull apart. The Serra du Mar is the scar tissue from that slow, violent separation, a crumbling cliff face that was once the very brink of a brand new ocean. As the crust stretched and thinned, massive blocks of the continent slumped downward, while others were uplifted, creating the dramatic, fault-bounded topography we see today. This isn't just a cliff, it's a snapshot of a continent in the act of breaking in two. The evidence for this colossal rift is written in the stone itself. The cliffs are composed of a complex basement of ancient, crystalline rocks from the Precambrian era, overlaid in many places by volcanic sequences from the very eruptions that accompanied the continental splitting. In some areas, you can find stunningly preserved sequences of sedimentary rock, layers of sand and mud that were deposited in the brand new basins forming between the fracturing continents. These layers are like pages in a history book, recording the environmental changes from arid deserts to deep lakes that filled these nascent valleys. For geologists, the Serra du Mar is a world-class laboratory. By studying the orientation of faults, the composition of volcanic rocks, and the fossils within the sedimentary layers, they can reconstruct the precise stresses and strains that tore Gondwana apart and set the stage for the Atlantic Ocean's birth. This geological drama created a stage for a biological spectacle of staggering proportions. The constant moisture from the ocean winds condensing on the steep slopes has given rise to the Mata Atlantica, or Atlantic forest, one of the most biodiverse and critically endangered ecosystems on Earth. The extreme variation in altitude from sea level to peaks over 2,000 meters creates a multitude of microclimates packed into a relatively narrow strip of land. This has led to an explosion of life found nowhere else. An estimated 70% of the tree species, 85% of the primates, and 39% of the mammals here are endemic. The cliffs provide isolated mountaintop refuges, often called sky islands, where unique species like the tiny, critically endangered golden lion tamarin evolved in splendid isolation, a living legacy of the ancient geography that isolated them. For the human story of Brazil, the Serra du Mar was both a formidable barrier and a vital protector. Long before European arrival, indigenous groups like the Tupi-Guarani inhabited the coastal strip and the forested slopes, using the rugged terrain to their advantage. The cliffs provided natural fortifications and a wealth of resources from the rich forest. When the Portuguese arrived in the 16th century, they initially clung to the coast, daunted by the seemingly impenetrable wall of mountains. However, they soon discovered passes and river valleys that cut through the escarpment, most famously the Paranapiacaba route, which became the path for the lucrative trade of gold and slaves from the interior highlands down to the port of Santos. The Portuguese also built fortified towns like Paraty, nestled at the foot of the cliffs, using the natural harbor and the mountain barrier for defense against pirates and rival empires. Today, the Serra du Mar stands as a monument to both natural wonder and the urgent need for conservation. The very cities that grew from its resources, Rio de Janeiro, Sao Paulo, Santos, now press against its foothills, threatening the forest with urban sprawl and pollution. Despite this, vast sections are now protected within a network of state parks and biological reserves, becoming a global hotspot for ecotourism. Adventurers hike its ancient trails, rock climbers scale its weathered faces, and scientists continue to make new discoveries in its secluded valleys. The Serra is a powerful reminder that the forces that shape continents also shape the destiny of every living thing upon them. A cliff that witnessed the birth of an ocean and now guards an irreplaceable treasure of life. Now we travel to the most extreme and enigmatic continent on Earth, Antarctica. Here, buried beneath a colossal sheet of ice that averages over 1 mile thick, lies one of the planet's most significant and utterly forgotten borders, the northern face of the Trans-Antarctic Mountains. This isn't just a mountain range, it's a geological titan that stretches for over 3,000 kilometers, cleaving the entire continent in two. Its northern escarpment was once a dramatic coastline, the very edge of the East Antarctic Craton, a stable, ancient chunk of continental crust that was the heart of the supercontinent Gondwana. This mighty cliff face formed a natural boundary, separating this core landmass from other, now dispersed fragments like Australia and South America before they all drifted apart. Today, this entire landscape is entombed in ice, a frozen ghost of a border that hasn't seen the sun for millions of years. We cannot stand before it. We can only unveil its secrets through technology, using ice-penetrating radar and satellite data to map the hidden contours of the rock far below the surface. This remote sensing has revealed a stunning truth. The profile of this ancient cliff remains remarkably intact, a silent, petrified wave frozen in geological time. The rock that makes up this hidden wall is unbelievably ancient, with some formations dating back well over 1 billion years to the Precambrian era. These are some of the most stable and oldest rocks on Earth, and they hold within them a completely different history of Antarctica, one that is warm, green, and teeming with life. The most profound evidence for this comes from the few exposed peaks and dry valleys that poke through the ice sheet, acting as natural windows into the deep past. Here, paleontologists have made discoveries that rewrite our understanding of this frozen desert. They have found extensive fossilized remains of Glossopteris trees, a distinctive prehistoric fern that was common across all the southern continents. Finding their imprints in Antarctic sandstone is like finding a palm tree fossil in the Arctic. It's a definitive clue that this land was once part of a warmer, vegetated world. Even more astonishing are the discoveries of fossilized amphibians and reptilian precursors, proving that Antarctica was not an isolated wasteland but a lush, connected corridor for life moving between the other Gondwanan continents. This brings us to a concept that is critical to understanding our planet's dynamism. Antarctica was not always at the South Pole. The continent's dramatic climate shift is a story of continental drift on a grand scale. For tens of millions of years, Antarctica remained nestled in a more temperate latitude, connected to Australia and South America. This allowed for the free exchange of species and supported vast forests. It was only after it finally broke away and became isolated, drifting over the South Pole and surrounded by the newly formed Antarctic Circumpolar Current, that its fate was sealed. This current acts like a massive, chilling moat, isolating the continent from warmer ocean waters and allowing the ice sheets to form and eventually bury the entire landscape, including the great cliff of the Trans-Antarctic Mountains, under a crushing dome of ice. The very force that is causing global concern, climate change, is now acting as a reluctant partner in unveiling this lost world. As temperatures gradually rise, the ice sheets are melting and retreating at an accelerating pace, particularly along the flanks of the Trans-Antarctic Range. This glacial retreat is exposing more and more of the mountain's northern face, revealing rock that hasn't been touched by air for 15 million years. For scientists, this is a double-edged sword. While it presents an unprecedented opportunity to study this pristine ancient boundary directly, taking rock samples and examining newly exposed fossils in detail, it also signals a profound and potentially irreversible alteration of the Antarctic landscape. Each new exposure offers a clearer glimpse into the anatomy of the forgotten cliff and the climate history locked within its layers, helping us predict how our own world might respond to continued warming. This ongoing revelation in the planet's most remote frontier perfectly sets the stage for our next destination, a border that needs no radar to uncover, a cliff so culturally and geographically significant that it has defined the divide between two continents for centuries. Leaving behind the frozen, hidden frontier of Antarctica, we now journey to a border that is anything but concealed, a place where the division between continents is not just a geological fact but a concept deeply embedded in human thought for millennia. This is the western escarpment of the Ural Mountains in Russia, a sprawling, forest-clad wall of rock that has served as the most famous and enduring continental divide in human history, the traditional boundary between Europe and Asia. This isn't a line drawn arbitrarily on a map by modern cartographers. Its significance stretches back over 2,000 years to the ancient Greek geographers who first pondered the limits of the known world. For them, this rugged chain formed the eastern edge of Europe, a natural barrier separating their civilized world from the vast, mysterious lands of Asia. Standing before these mountains, one is standing at a crossroads of human geography, where a cliff face became an idea that shaped empires, cultures, and the very way we conceptualize our world. The geological story of the Urals is one of ancient titanic violence, a monumental collision that occurred over 300 million years ago. This was the final, climactic act in the assembly of the supercontinent Pangea, when the ancient continental block of Baltica, which would become Europe, slammed into the massive Siberian craton to the east. The force of this impact was so immense that it crumpled the oceanic crust that once separated them, thrusting it upward to form a mountain range that likely rivaled the modern Himalayas in scale. The Western Escarpment is the most dramatic remnant of this event, the steep, uplifted edge of the European plate where it overrode the closing ocean. Today, these mountains are worn down and softened by eons of erosion, but their underlying structure remains a textbook example of a continental suture zone, a place where two separate landmasses were permanently welded together. For geologists, the Urals are a pristine, open-air museum, offering a perfectly preserved snapshot of a Paleozoic mountain-building event that is often obscured by younger tectonic activity elsewhere on the globe. This incredible geological history did more than just build mountains. It forged a treasure chest of almost unimaginable wealth. The same colossal forces that crumpled the crust also concentrated a stunning array of mineral deposits along the length of the range. The Urals are phenomenally rich in precious and industrial metals, including vast reserves of platinum, gold, copper, iron, and a host of rare gemstones like emerald and alexandrite. This subterranean wealth has acted as a powerful magnet for human activity for centuries, fundamentally shaping the region's destiny. It began with the Stroganov family in the 16th century, who built a vast fortune from salt and fur before funding the Cossack expeditions that began the systematic exploration and exploitation of the range. This mineral rush reached its zenith in the 18th century, when Tsar Peter the Great, eager to fuel his empire's growth, established a massive mining and metallurgical industry in the Urals. Entire cities like the industrial giant Yekaterinburg were founded specifically to manage this extraction, literally building their fortunes from the bones of the ancient continental collision. Yet, long before Tsars and industrialists arrived, the Urals held a profound and sacred significance for the indigenous peoples who called these slopes home. For cultures like the Mansi and the Conti, the mountains were not a border to be crossed but a living, spiritual entity to be revered. Their rich animist traditions are filled with myths and legends that personify the peaks and cliffs. They believed the highest points were the dwellings of powerful gods and spirits, and that the unusual rock formations were frozen giants or petrified ancestors. The watershed along the crest of the range was seen not just as a geographical divide, but as a boundary between the human world and the spirit world. This deep cultural and spiritual mapping of the landscape stands in poignant contrast to the political and economic divisions that would later be imposed upon it, reminding us that a single cliff can hold many layers of meaning. Despite the intense industrialization that has marked the last 3 centuries, vast stretches of the Urals remain remarkably wild and pristine. The southern reaches are dominated by lush steppe landscapes, while the northern sections plunge into deep, boreal taiga forests and trackless wilderness. These protected areas are crucial for scientists as they allow for the study of the mountain's geology and ecology without significant human alteration. Researchers can examine the clean exposures of rock layers to understand the precise mechanics of the ancient continental collision, study the unique plant life that has adapted to the mineral-rich soils, and trace the evolutionary paths of species that were isolated on either side of this natural barrier. The Ural Mountains stand as a powerful testament to the enduring legacy of plate tectonics, a place where a line on a map is backed by the immense physical reality of a cliff that once divided worlds. Our journey now takes us from this well-known divide in the northern hemisphere to a monumental escarpment on the opposite side of the globe, one that defined the edge of an ancient and isolated continent as it drifted into its modern place. Running like a vast, unbroken spine down the entire eastern coast of Australia, the Great Escarpment is a geographical titan that commands the landscape. This is not a single cliff but a continuous, winding system of steep slopes and dramatic drop-offs, stretching over 3,000 kilometers from the tropical north of Queensland all the way to the temperate south of Victoria. It represents the crumbling, weathered remnant of what was once the continent's raw, dramatic edge, a colossal cliff face that plummeted into the Pacific Ocean over 80 million years ago. This monumental feature was born from the same tectonic divorce that separated Australia from Antarctica. As the landmasses drifted apart, the eastern edge of the Australian continent uplifted, creating a towering continental margin. What we see today is the deeply eroded skeleton of that original coastline, a breathtaking testament to the power of erosion which has carved back the cliff face over millions of years, leaving behind a spectacular plateau that now looks inland over a vast, fertile coastal plain. The influence of this immense wall of rock on the continent's climate and life is nothing short of profound. Acting as a formidable barrier to the moisture-laden winds blowing in from the Tasman Sea, the escarpment forces this air to rise, cool, and release its burden as rain. This creates a stark environmental divide. The seaward side of the range is drenched in rainfall, nurturing lush rainforests that are among the oldest on the planet, like those in the Gondwana Rainforest's World Heritage Area. Just a short journey to the west, beyond the crest of the escarpment, the air descends, warming and drying out to create the more arid woodlands of the interior tablelands. This dramatic variation in climate over a short distance has made the region a cradle of biodiversity and a haven for species that exist nowhere else on Earth. Isolated for eons on these high plateaus and in the deep, moist gullies, animals like the ancient Wollemi pine, a living fossil thought extinct until its dramatic rediscovery in 1994, and the elusive frog-like pouched frog have evolved in splendid isolation, offering a direct window into Australia's prehistoric past. For the Aboriginal peoples of Eastern Australia, the Great Escarpment is far more than a geological feature. It is a living, breathing part of their cultural and spiritual identity, deeply woven into the very fabric of the Dreamtime. For tens of thousands of years, nations like the Gundungurra in the Blue Mountains and the Gumbayngur farther north have known these cliffs as both a provider and a protector. The intricate network of sandstone overhangs and caves within the escarpment provided vital shelter, while the varied ecosystems it sustained offered a rich abundance of food and medicine. More importantly, the dramatic landscape is central to their creation stories. Specific rock formations, waterfalls, and lookouts are not random features. They are the petrified remains of ancestral beings, the sites of epic Dreamtime battles, or sacred pathways used by creator spirits. This deep, spiritual connection is expressed through a powerful artistic tradition, with hundreds of rock art sites adorning the sandstone walls. These galleries, featuring stencils, engravings, and paintings, are not merely art. They are a historical record, a map of cultural knowledge, and a sacred text etched into the very stone of the escarpment itself. In the modern era, this ancient landscape faces a new set of challenges that threaten its integrity. The very qualities that make it unique, its mineral wealth, its breathtaking views, its proximity to growing cities like Sydney and Brisbane, have placed it under immense pressure. Expanding urban sprawl nibbles at its foothills, while mining operations seek to extract coal and other resources from its geological layers. The influx of tourists, while vital for the economy, brings with it the risks of erosion on walking tracks, pollution, and the potential disruption of fragile ecosystems. Recognizing these threats has sparked a powerful and ongoing conservation movement. Large sections of the escarpment are now protected within a network of iconic national parks, including the Blue Mountains, Royal, and Border Ranges national parks. Conservationists and traditional owners often work in partnership, using a combination of cutting-edge science and tens of thousands of years of traditional ecological knowledge to manage fire regimes, control invasive species, and restore damaged habitats, ensuring this grand, ancient border continues to tell its story for generations to come. Stretching from the deep south of Alabama all the way to the Canadian border of Newfoundland, the Appalachian Mountains form the weathered, green backbone of eastern North America. To walk through the rolling hills of the Catskills or the misty valleys of the Alleghenies is to tread upon one of the most ancient and storied landscapes on the planet. These gentle, forested slopes are the deeply eroded roots of a geological giant, a mountain range that once rivaled the Himalayas in sheer scale and drama. The eastern cliffs of this range, now softened by time, were once the dramatic, towering edge of the ancient continent of Laurentia, the primordial core of North America. For millions of years, this colossal cliff face was the continent's Atlantic coastline, a silent sentinel gazing out over an ancient, vanished ocean known as Iapetus. This peaceful scenery belies a history of incredible violence, the quiet aftermath of the colossal collision that welded continents together to form the supercontinent Pangea over 300 million years ago. The rock record here is like a multi-volume history of the Earth, with each layer a chapter written in stone. The story begins with the birth of the Appalachian Range itself, an event geologists call the Alleghenian orogeny. This was the climactic, slow-motion crash between Laurentia and the northwestern corner of what is now Africa. The force of this continental collision was so immense that it crumpled the entire eastern seaboard, thrusting up a mighty mountain chain and literally folding the crust itself. The evidence is everywhere for those who know how to look. In road cuts and river gorges, you can clearly see the layers of sedimentary rock, old seafloors, river deltas, and sand dunes that have been bent and tilted almost vertically, standing on end like the pages of a book that has been slammed shut. Within these layers, fossils of ancient marine creatures like trilobites and brachiopods are common. a silent testament to the fact that these highlands were once a deep ocean basin. Later, during the Carboniferous period, the vast, swampy lowlands at the foot of these young mountains became the graveyard for gigantic tree ferns and primitive forests. Over eons, these organic remains were buried and compressed, slowly transforming into the immense coal deposits that would later fuel the Industrial Revolution and shape the economy of an entire nation. This ancient geological wall would go on to play a pivotal and unexpected role in the much more recent story of human history in North America. For European colonists pushing westward from their initial settlements on the Atlantic coast, the Appalachian Range presented a formidable and frustrating barrier. Its endless, rugged ridges, dense forests, and lack of easy passes seemed to mark the western limit of expansion for generations. This physical barrier had profound political consequences. In an attempt to avoid conflict with Native American nations and French settlers to the west, the British Crown issued the Royal Proclamation of 1763, which legally forbade American colonists from settling west of the Appalachian Mountains. This decree, intended to maintain order, became a major source of grievance for the colonists, fueling a desire for independence and self-determination that contributed directly to the American Revolution. The mountains, in effect, became a geographical catalyst for a political revolution. Yet, for all the challenges they posed to expansion, the Appalachians also became a profound source of inspiration. In the 19th century, this landscape gave birth to America's first major artistic movement, the Hudson River School. Painters like Thomas Cole and Frederick Edwin Church saw not an obstacle, but a sublime, almost divine wilderness. They ventured into the Catskills and the White Mountains, transforming their canvases into breathtaking, romantic vistas that captured the awe-inspiring power of the American wilderness. Their work did more than just create art. It helped forge a new national identity, one rooted in the grandeur and promise of the natural world. This artistic reverence helped lay the groundwork for the conservation movement, inspiring the protection of natural wonders across the continent. The mountains also provided a refuge and a cultural cradle for the communities that settled in their hollows and valleys. The distinct folk music, crafts, and traditions that developed in the isolation of these hills are a direct legacy of the geology that shaped their world. The story of the Appalachians is far from a closed book. Modern geologists continue to probe its secrets, using advanced technology to understand the deep forces that built it. They employ seismic imaging to map the structure of the crust far beneath the surface, revealing the geometry of the ancient faults that thrust these mountains skyward. They study the minute minerals within the rock to precisely date the timing of the continental collisions. And perhaps most fascinatingly, the Appalachian Range is now a key piece of evidence in the fascinating puzzle of supercontinent cycles. The same mountain-building processes that created these cliffs are also at work today, building the Himalayas. And by studying the worn-down roots of the ancient Appalachians, scientists can effectively peer into the future, gaining a preview of what the Himalayas might look like hundreds of millions of years from now, after erosion has had its way. This ancient, quiet range continues to serve as a crucial classroom, teaching us about the past, present, and future of our dynamic planet. From this foundational border of North America, we now cross the Atlantic to explore a cliff system born from a much more recent and ongoing continental confrontation, one that continues to shape the landscape and history of the Mediterranean world. From the worn-down roots of the Appalachians, we now travel across the Atlantic to a landscape where the collision of continents is not a distant memory, but a vibrant, ongoing process. In the northern reaches of Algeria and Tunisia, the Tel Atlas Mountains rise abruptly from the Mediterranean coast, their steep, rugged cliffs telling a story of a relentless tectonic struggle that is still shaping the world today. This dramatic escarpment is far more than a scenic backdrop. It is the active front line in the slow-motion collision between the African and Eurasian plates. For millions of years, the African plate has been pushing northward, its leading edge sliding beneath the massive Eurasian plate in a process called subduction. This ongoing geological conflict is the very engine that created the Mediterranean Sea Basin, crumpling the Earth's crust to form the Tell Atlas Range and its formidable cliffs, which stand as a permanent monument to the immense, unstoppable forces brewing deep beneath our feet. The evidence of this tectonic drama is etched into the very economy and landscape of the region. The incredible pressures and heat generated by the subduction process have cooked the organic, rich sediments of the ancient Tethys ocean floor, slowly transforming them over eons into vast reserves of oil and natural gas. These hydrocarbon treasures are often trapped in unique geological features called salt domes, where underground pillars of salt, pushed upward by the immense tectonic pressures, have created perfect natural storage tanks deep within the rock. This has made the Tell Atlas region a vital energy province for North Africa, linking its deep geological past directly to the modern global economy. The same forces that built these cliffs also forged the resources that now power entire nations, a direct and powerful reminder of how planetary-scale processes intimately shape human destiny. Human history is layered upon this geological foundation like strata itself. The fertile valleys nestled between the steep slopes of the Tell Atlas have been coveted and contested for millennia. The Berbers, the indigenous people of North Africa, have inhabited these mountains since prehistoric times, building fortified villages known as caissars on high ridges for defense and taking advantage of the varied microclimates for farming. Their presence is a testament to adaptation and resilience in a dramatic landscape. Then came the Romans, who saw the strategic value of this natural rampart. They constructed a network of formidable fortifications and watchtowers along the crests, most famously the limes of North Africa, using the cliffs as a natural barrier to control movement and defend their prosperous African provinces from desert raiders. The ruins of cities like Timgad and Jaimila, now UNESCO World Heritage Sites, stand as silent witnesses to this era, their stones quarried from the very bones of the mountains that protected them. Despite its solid, imposing appearance, this is a landscape in constant, gradual flux. The original, sharp cliff lines raised by tectonic force have been continuously softened and altered by two powerful, opposing agents: erosion and earthquakes. Seasonal rains carve deep gullies into the slopes, carrying sediment down to fill the valleys, while wind slowly scours the higher ridges. More dramatically, the same tectonic stresses that built the range periodically release their energy in violent earthquakes that can literally reshape the topography in minutes, triggering landslides that erase old features and create new ones. This combination of slow wear and sudden violence means the cliff we see today is not the same cliff that confronted a Roman legionary 2,000 years ago. It is a dynamic, ever-changing feature, a testament to the fact that even the mightiest geological borders are ultimately temporary in the grand sweep of planetary time. Today, the Tell Atlas remains an absolutely crucial outdoor laboratory for geologists and seismologists seeking to understand the complex dance of continents. By studying the folded rock layers, mapping active fault lines, and monitoring the frequent seismic activity, scientists can piece together the precise mechanics of how plates collide in a Mediterranean-style convergence. This research is not merely academic, it is vital for assessing earthquake risks for the millions of people who now live in the shadow of these cliffs. The region provides a clear and present model for understanding similar subduction zones around the world, helping us prepare for the inevitable seismic events they generate. The Tell Atlas, therefore, is more than a forgotten cliff. It is a living, breathing border, a place where the deep past actively informs our understanding of the present and future. This journey along an active plate boundary now takes us to a place of extreme stillness and cold, to a cliff that has been locked in a deep freeze for millennia, guarding the edge of one of Earth's most ancient continental hearts. Venturing into the stark and formidable landscapes of eastern Siberia, we encounter a place where the very concept of cold takes on a new meaning. The Verkhoyansk Range is a world of extremes, a sprawling arc of mountains that contains some of the most remote and punishing cliffs on the planet. This is not just a geographical location, it is a deep freeze for geological time, a place where the rocks tell a story of unimaginable antiquity. These cliffs were once the dramatic eastern margin of the Siberian Craton, one of the oldest and most stable pieces of continental crust on Earth. Think of a craton as the ancient, unyielding heart of a continent, a foundational block that has resisted being torn apart by billions of years of tectonic chaos. The Verkhoyansk cliffs are the preserved edge of this primordial heart, a fossilized coastline that once bordered ancient, long-vanished oceans, standing as a silent, frozen sentinel against eons of planetary change. The rock record here is like opening a history book to its very first chapters. Within these cliffs, geologists find astonishingly well-preserved evidence of Proterozoic ocean floors, dating back well over 1 billion years. You can find sequences of rock that were once layers of mud and silt settling on a deep seafloor, since hardened into shale and siltstone and then thrust upward into the sky. Even more fascinating are the signs of ancient mountain-building events, known as orogenies, that occurred long before the dinosaurs ever walked the Earth. The range itself is a product of a more recent, but still ancient, collision when a microcontinent or a volcanic island arc smashed into the steadfast Siberian Craton during the Mesozoic era. This collision crumpled the crust, folding and faulting those ancient seafloor rocks and pushing them up to form the mountains we see today. For scientists, it's a unique opportunity to study the processes of both ocean formation and mountain building in a single, spectacularly exposed sequence. This harsh and majestic landscape is far from empty. For centuries, it has been home to resilient indigenous peoples, primarily the Yakuts and the Evenks, whose cultures and spiritual beliefs are deeply intertwined with the formidable geography. In their rich oral traditions and shamanic practices, the Verkhoyansk Range is not merely a physical barrier but a profound spiritual frontier. They view these towering cliffs and deep valleys as a liminal space, a boundary between the everyday human world and the unseen spirit world. Specific peaks and rock formations are often considered the dwellings of powerful spirits or ancestors, and the extreme cold and long winter darkness are woven into myths that explain the creation and order of the universe. Their survival in this environment, based on reindeer herding and hunting, demonstrates a profound understanding and respect for a land that to outsiders seems utterly inhospitable. Their legends are not just stories, they are a cultural map of a powerful and animate landscape. Today, a powerful and global force is acting as a key to unlock new secrets from this frozen repository of the past. Climate change is causing the Arctic to warm at a rate much faster than the rest of the planet, and the Verkhoyansk Range is experiencing this thaw with dramatic effect. The permafrost ground that has been permanently frozen for thousands of years is now melting at an accelerating pace. This is revealing geological features and fossils that have been hidden from view since the last ice age. Paleontologists are making incredible discoveries as the ice retreats, uncovering the preserved remains of Pleistocene megafauna like woolly mammoths, woolly rhinoceroses, and steppe bison, their fur and flesh sometimes startlingly intact. For geologists, the thawing slopes are exposing fresh rock faces, providing new windows into the structure and composition of the ancient cliffs without the need for arduous drilling. While this melting presents an ecological crisis for the fragile Arctic ecosystem, it has also turned the region into an unprecedented open-air laboratory, offering a fleeting chance to recover lost chapters of Earth's history before they decay or are reburied. Our journey from the frozen, ancient heart of Siberia now draws us toward a landscape of breathtaking contrast, a place not of ice and rock, but of towering tabletop mountains, steamy rainforests, and biological wonders that seem ripped from a lost world. We now turn our gaze to the immense Guiana Shield of South America, where cliffs that border the ancient continent of Amazonia hold secrets of Earth's very beginnings. Rising from the steamy rainforests of Venezuela, Guyana, and Brazil, the Guiana Shield is home to one of the most surreal and ancient landscapes on our planet. Here, the concept of a cliff is redefined. These are not mere slopes of rock. They are the towering, vertical walls of colossal tabletop mountains known as tepuis, a word from the Pemon people meaning house of the gods. And that name is perfectly fitting, for these breathtaking formations are the crumbling, weathered remnants of a cliff so vast it once defined the entire northern edge of the ancient continent of Amazonia, a primordial landmass that existed long before it merged with others to form the supercontinent of Gondwana. The tepuis are not just geological features. They are islands in the sky, isolated fortresses of sandstone that have been watching over the green ocean of the rainforest for nearly 2 billion years, making them some of the most ancient rock formations anywhere on Earth. The story of their creation is a masterpiece of geological patience and power. Around 1.8 billion years ago, this entire region was a vast basin, where layer upon layer of sand and sediment were deposited by mighty rivers, eventually solidifying into a gargantuan slab of quartz sandstone and conglomerate rock that was over 3,000 meters thick. Then, for eons, the forces of tectonics gently uplifted this entire block of crust. Once elevated, the real artist went to work. Erosion, wind and water, acting with unimaginable patience over hundreds of millions of years, began to scour away the softer rock surrounding this hardened sandstone plateau. What was left behind were these immense, flat-topped towers, their sheer cliffs standing as the last defiant bastions of that original, continental-scale landform. Geologists see the tepuis as the preserved roots of a vanished world, a direct window into the Proterozoic eon when Earth's atmosphere was still young and life was only beginning its long, slow journey toward complexity. This profound geological isolation has created a real-life lost world, a phrase famously inspired by Sir Arthur Conan Doyle's novel set on a tepui. Because the cliffs are so sheer and high, often over 1,000 meters tall, the ecosystems on top of these mountains have been completely cut off from the forest below for millions of years. This separation has allowed evolution to experiment in spectacular isolation. The summits of tepuis like Mount Roraima and Oyon Tepui are worlds unto themselves, with their own unique weather patterns, constantly shrouded in mist and watered by frequent rain that feeds bizarre, black water rivers. The life that has evolved here is found nowhere else on the planet. You can find carnivorous plants that have adapted to the nutrient-poor soil by trapping and digesting insects, unique orchids that cling to the bare rock, and endemic species of frogs and insects that have never set foot on the forest floor. These sky islands are living museums, preserving fragments of ancient ecosystems that have vanished from the rest of the world, offering scientists an unparalleled glimpse into the deep biological past. For the indigenous Pamon people who have lived in the shadow of these giants for centuries, the tepuis are infinitely more than just physical landmarks. They are the very center of their spiritual and cultural universe. In Pamon cosmology, the cliffs are sacred, believed to be the home of powerful spirits and deities. They are not to be climbed lightly, as they are seen as a boundary between the human world and the spirit world. One of their most important creation myths tells of a great tree that once held all the fruits and tubers in the world. A legendary hero cut it down, and when it fell, it created the flat top of Mount Roraima and caused a great flood that shaped the land. Every waterfall that cascades down the immense cliffs is seen as a spiritual connection, and the caves that pockmark the bases of the tepuis are often considered entrances to the underworld. This deep, reverential relationship stands in stark contrast to the modern world's view of the landscape as a resource for tourism or mining, highlighting a cultural clash over the meaning and value of this ancient border. Today, the Guiana Shield faces a precarious future. Its very uniqueness makes it a target for adventure tourism, with visitors eager to scale the cliffs and explore the summits, potentially introducing invasive species that could devastate the fragile endemic ecosystems. The region is also rich in mineral wealth, including diamonds and gold, leading to pressure for mining operations that could scar the landscape irreparably. However, a significant portion of this ancient geological wonder is now protected within vast national parks like Canaima in Venezuela, which is a UNESCO World Heritage Site. The challenge for conservationists is to balance the preservation of this irreplaceable window into Earth's deep past with the rights and knowledge of the indigenous peoples and the economic pressures of the modern world. The Guiana Shield Cliffs stand as a monumental reminder of our planet's incredible age, holding stories of continental formation, biological wonder, and human spirit in their 2-billion-year-old stone. This journey to one of Earth's most ancient and isolated borders now leads us to a cliff of an entirely different nature, one that was not a barrier of rock, but a bridge of land connecting continents and guiding the very peopling of the Americas. Now we venture into one of the most profound and influential borders in all of human history, a place that is not a cliff in the traditional sense, but a lost landscape of immense importance. This is the story of the Bering Land Bridge, or Beringia, a vast, now submerged plain that once connected the continents of Asia and North America. While we often picture it as a flat corridor, its edges were defined by significant cliffs and steep escarpments, both on the Siberian and Alaskan sides, which acted as the literal gateposts for one of the most significant migrations of life in our planet's history. During the peak of the ice ages, so much of the world's water was locked up in colossal glaciers that global sea levels plummeted, exposing the shallow continental shelf between the two landmasses. What is now the stormy, 55-mile-wide Bering Strait was transformed into a broad, 1,000-mile-wide expanse of grasslands, rivers, and gentle hills bounded by these ancient cliffs. This wasn't a temporary landfall. It persisted for thousands of years, a constantly changing landscape that served as a bridge, a barrier, and a home. The existence and topography of this forgotten border are not just speculation. They are mapped through the sophisticated tools of modern science. Oceanographers and geologists use multi-beam sonar to create detailed, three-dimensional maps of the seafloor, revealing the ghostly contours of this lost world. These images show the old river valleys that once carved through the plain, the basins of ancient lakes, and yes, the unmistakable profiles of submerged cliffs that once lined its margins. Even more telling are the core samples extracted from the seabed sediments. These long cylinders of mud and rock are like time capsules, containing layers of pollen, plant fossils, and even the bones of animals that once roamed there. This evidence paints a vivid picture of Beringia not as a barren, icy wasteland, but as a productive steppe ecosystem, a frigid version of the Serengeti, teeming with life and capable of supporting large populations of grazing animals and the humans who followed them. This land bridge, with its defining cliffs acting as funnels, became the ultimate superhighway for intercontinental exchange. It was a two-way street for the migration of plants, animals, and people. From Asia into the Americas came species like the ancient bison, the woolly mammoth, the camel, and the first human pioneers. In return, horses and probably certain carnivores moved back into Asia. This transfer of life forever altered the biological destiny of two continents. The arrival of humans in the Americas, likely tracking herds of game across this fertile plain, is one of the pivotal chapters in the story of our species, leading to the peopling of an entire hemisphere. The cliffs that framed this route were not just silent witnesses. They provided shelter, vantage points, and geographical markers for these journeying groups, guiding their progress into a new world. For the indigenous peoples whose ancestors made this incredible journey, Beringia is not a forgotten abstraction. It is a foundational chapter in their living history and oral traditions. Communities like the Yupik and Inuit, whose homelands straddle both sides of the Bering Strait, have maintained cultural and familial ties across this water for centuries. Their rich storytelling traditions often speak of a time when the land was continuous, of journeys made by foot, and of a connection between peoples that was severed by the rising waters. These are not mere legends. They are historical records encoded in oral history, reflecting a deep understanding of a landscape that their ancestors knew intimately. The cliffs and landmarks that are now underwater may still be remembered in the names and stories passed down through generations, linking the present to a vast, submerged past. Today, this ancient, hidden border is once again moving to the forefront of scientific and geopolitical interest, driven by the powerful forces of climate change. As the Arctic warms at an alarming rate, the sea ice that has long made this region inaccessible is retreating, opening new shipping lanes and revealing the seafloor to renewed exploration. This has sparked a race to better understand Beringia's geology, not just for historical purposes, but to assess potential resources and navigate new territorial claims. Furthermore, the melting permafrost along the exposed coastlines of Alaska and Siberia is eroding at an accelerated pace, threatening coastal villages but also occasionally revealing spectacularly preserved fossils from the Ice Age fauna that once called the land bridge home. This renewed focus ensures that the story of this submerged border is still being written, a reminder that the past is never truly lost, but simply waiting for the right conditions to share its secrets once more. Deep beneath the turquoise waves of the Tasman Sea, off the eastern coast of Australia, lies one of the planet's most spectacular and little-known geological secrets. This is the Lord Howe Rise, a vast, submerged continental fragment that is essentially a drowned world, a lost piece of real estate that sank beneath the waves tens of millions of years ago. The most dramatic features of this sunken realm are its cliffs, sheer, underwater escarpments that once formed a monumental boundary, not between two separate continents, but between the ancient supercontinent of Gondwana and a sliver of itself that was slowly pulling away. These cliffs were the original edge of what would become the continent of Zealandia before it, too, mostly vanished beneath the Pacific Ocean. Today, these formations are hidden in the deep, a ghostly coastline existing in perpetual twilight, holding silent witness to one of the most dramatic instances of continental drowning in Earth's history. Unraveling the mysteries of this sunken border requires not hiking boots and rock hammers, but sophisticated deep-sea technology. Scientists rely on submersibles, remote-operated vehicles, and advanced sonar mapping to act as their eyes and hands in this alien environment. What they have discovered is nothing short of revolutionary. Core samples extracted from the sediment near these underwater cliffs contain a telltale mix of fossilized pollen from land-based plants and the microscopic shells of shallow water marine organisms. This is the ultimate smoking gun, proving that this was not always deep ocean. These findings indicate that the Lord Howe Rise was once an emergent landmass, likely a chain of islands or even a small continent with its own rivers, forests, and unique ecosystems, a verdant world that stood high and dry before its eventual descent. The rock types themselves, continental granites and sandstones found on the deep seafloor, confirm that this is not oceanic crust but a true, albeit flooded, continent. The presence of this massive, submerged plateau and its defining cliffs continues to exert a powerful influence on the modern world, shaping the very ocean above it. This hidden topography acts like a giant speed bump on the seafloor, disrupting the flow of major ocean currents such as the East Australian Current. As these powerful currents hit the rise, they are deflected upward, carrying cold, nutrient-rich waters from the abyss toward the sunlit surface. This process, known as upwelling, fertilizes the ocean, triggering massive blooms of phytoplankton that form the base of an incredibly rich marine food web. This makes the region a globally significant hotspot for biodiversity, attracting everything from great white sharks and tuna to migrating whales and seabirds. The cliffs themselves provide crucial habitat, their rocky faces offering a foothold for deep-sea corals, sponges, and a host of other creatures that transform the barren rock into vibrant, living cities in the deep. The story of how this border ended up a mile underwater is a classic tale of tectonic intrigue, centered on the concept of continental thinning and rifting. Around 80 to 90 million years ago, the enormous weight of the supercontinent Gondwana began to cause its own downfall. The crust beneath it became stretched and heated from below by upwellings in the mantle. This caused the land to thin and weaken, much like a piece of taffy being pulled apart. Eventually, a massive chunk, what we now call Zealandia, began to peel away from what is now Australia. As it drifted, it stretched and thinned even further, becoming less buoyant. Unlike the clean, sharp break of a tectonic plate boundary, this was a slow, sinking demise. The land simply became too thin and dense to float high enough above the mantle, and it gradually descended beneath the waves, its dramatic cliffs becoming a drowned coastline, preserved in the cold, dark silence of the deep sea. Research here is providing crucial clues to one of geology's most fascinating new concepts, the existence of Earth's lost continents. Zealandia, of which the Lord Howe Rise is a part, is the most recently recognized and most clearly defined of these submerged continental fragments, but it is not alone. Its discovery has prompted geologists to re-examine other ocean basins for similar hidden continents, rewriting our understanding of how continents can break apart and evolve. Furthermore, by studying the precise depth and erosion patterns of these sunken cliffs, scientists can create sophisticated models of past sea level change. The cliffs act as a permanent benchmark, allowing researchers to calculate how much of Zealandia's submersion was due to tectonic sinking and how much was due to global sea level rise from past ice age cycles. This makes the Lord Howe Rise not just a geological curiosity, but a vital key to understanding the complex interplay between the solid Earth and the ocean above it, a hidden border that continues to shape our planet's story. This exploration of a continent lost to the deep now leads us to a cliff of a very different fate, one that was not drowned but instead was forged in the fiery collision of ancient microcontinents, shaping the very foundation of the eastern North American coastline. Tucked away within the rolling hills and rocky coasts of New England and Canada's maritime provinces lies a geological ghost, the faded memory of a border that once defined an entire world. These landscapes, now known for their quaint villages and autumnal splendor, are the deeply eroded roots of the ancient Acadian Mountains, a range whose mighty cliffs once marked a frontier far more significant than any national boundary. These cliffs were the dramatic edge of a lost microcontinent named Avalonia, a wandering landmass that broke free from the supercontinent Gondwana and embarked on a long, slow journey across the ancient Iapetus Ocean. Its ultimate destiny was a cataclysmic collision with the sturdy northern coast of Laurentia, the primordial heart of North America. The Acadian cliffs were the leading edge of that impact, the crumpled prow of a continent that no longer exists as a separate entity, its story now written in the folded stone beneath our feet. The evidence of this ancient violence is embedded in the very rock that forms the foundation of the northeastern seaboard. Unlike the sedimentary layers that dominate much of the Appalachians, the Acadian region is a chaotic and fascinating mix of volcanic and sedimentary rocks, a testament to the complex geology of a traveling microcontinent. As Avalonia drifted northward, volcanic island arcs erupted along its margins, adding new rock to its growing frame. When it finally collided with Laurentia, the force was so immense that it scrambled this geological inventory, thrusting slices of deep oceanic crust and mantle up onto the continent, creating formations known as ophiolites. For a geologist, hiking through the hills of Maine or New Brunswick is like walking across the ruins of that ancient collision. You can find pillow basalts that once cooled on a deep seafloor now sitting high atop a mountain, and volcanic ash layers that settled in quiet waters now tilted vertically, standing like stone sentinels guarding the secrets of the past. This monumental collision did more than just build a single mountain range. It laid the very groundwork for the continent we know today. The forces that raised the Acadian cliffs were a critical opening chapter in the larger story of the Appalachian Mountains. The energy from the Avalonia-Laurentia impact compressed the crust for hundreds of miles inland, creating a wide zone of weakness and deformation. This prepared the stage for the final and most dramatic act of Appalachian formation, the Alleghanian orogeny, when Africa itself would collide with this already complex margin to finish assembling the supercontinent Pangea. In essence, the Acadian cliffs were the first draft of the eastern North American coastline, a prototype that would be further refined and amplified by later continental collisions. The very shape of the Atlantic shore, from the rugged coves of Maine to the sweeping Bay of Fundy, ultimately follows the grain of these ancient mountain-building events. The legacy of this long-vanished cliff extends far beyond the realm of geology, silently shaping the course of human history in North America. When European settlers first arrived on these shores, they encountered a coastline that was frustratingly short on natural harbors and riven with rocky headlands. They did not know it, but they were navigating the eroded roots of the Acadian Mountains. The few excellent harbors they did find, like those at Boston and Halifax, were often located where glaciers had scoured out softer rock along the lines of ancient faults, weaknesses that were first created during the Avalonian collision. Conversely, the rivers that provided vital transportation routes into the interior, such as the Hudson and the Connecticut, often followed deep valleys that were carved along these same prehistoric fault lines. The initial success or failure of early colonial settlements was, in no small part, dictated by the invisible architecture of this half-billion-year-old cliff. Uncovering the full story of this forgotten border is an ongoing mission for modern geologists, a complex puzzle that requires piecing together clues from across the North Atlantic. The proof of Avallonia's journey is not just found in North America. Its matching pieces are scattered across the ocean. The distinctive rock sequences and fossil assemblages found in the Acadian regions of New England and Canada are virtually identical to those found in parts of southern Ireland, Wales, and England. This transatlantic correlation is the ultimate evidence that these lands were once seamlessly connected, part of the same wandering microcontinent that was later ripped apart by the opening of the modern Atlantic Ocean. Today, scientists use advanced techniques like seismic tomography and precise radiometric dating to map the deep faults and pinpoint the exact timing of the collision, slowly bringing the full, epic scale of the Acadian cliffs back into focus from the blur of deep time. Leaving the complex puzzle of the Acadian collision behind, we now journey to a landscape of stark and breathtaking simplicity, where the story of continental separation is written in the most dramatic terms imaginable. This is the Namibian Escarpment, a place where the very edge of Africa seems to crumble into the cold, blue vastness of the Atlantic Ocean. This is not a gentle slope. It is a monumental, 1,000-kilometer-long cliff face, a raw and spectacular scar that marks one of the cleanest breaks in the Earth's crust. This colossal drop-off is the preserved rupture point, the exact place where the supercontinent Gondwana was torn in two, sending South America drifting away on a journey of thousands of miles. The escarpment is the fossilized wound of that divorce, a crumbling wall that has stood for over 130 million years, watching the Atlantic Ocean widen inch by inch every year. To stand on its edge is to stand at the precipice of deep time, gazing out at an ocean that did not exist before the cliff itself was born. The evidence for this cataclysmic split is not hidden. It is exposed in layers of rock that read like a geological epic. As you move inland from the coast, you ascend a staircase of time. The lowest layers, exposed at the base of the escarpment, are the ancient, billion-year-old crystalline rocks of the African continental core. Above them lie the volcanic basalt layers that erupted as the continent first stretched and thinned, a testament to the fiery birth pangs of the new ocean. And capping it all are the much younger sedimentary rocks, the sand and gravel that filled the valleys of the newly formed rift. This perfect cross-section allows geologists to walk uphill through millions of years, directly observing the sequence of events from stable continent to continental rupture. The entire region is a single, glorious exhibit of plate tectonics in action, with the escarpment itself as the centerpiece. This ancient cliff is more than a geological marvel. It is one of the oldest and most arid deserts on Earth, and its extreme environment has created a living museum of evolutionary adaptation. The Namib Desert, which lies at the foot of the escarpment, is a land of surreal beauty and life pushed to its limits. The cliffs play a direct role in creating this harsh reality. The cold, north-flowing Bengla Current in the Atlantic Ocean chills the air above it, creating a dense marine fog that rolls inland. When this fog bank hits the sudden, steep wall of the escarpment, it is forced upward, condensing into a life-giving moisture that sustains a stunning array of endemic life. This is how the famous Welwitschia plant, a living fossil that can survive for over 1,000 years, survives, by drinking water from the air with its leaves. The fog also provides moisture for the incredible, otherworldly landscapes of the Sand Sea, where some of the tallest dunes on the planet are home to specialized beetles, geckos, and ostriches that have all evolved unique strategies to thrive in this hyper-arid world. The human story here is just as ancient and profound, painted literally onto the stone of the escarpment. Brandberg Mountain, a massive granite in Selberg that is the highest point in Namibia, is not just a geological feature, it is a sacred gallery. Its caves and overhangs are adorned with over 45,000 rock art images created by the Sand People over thousands of years. The most famous of these is the White Lady, a figure that likely represents a shaman in a ritual trance. These paintings are far more than art. They are a historical record of a deep spiritual connection to this landscape, depicting the animals they hunted and the cosmological beliefs that guided their lives. The escarpment provided them with shelter, vantage points, and a sense of place in a vast and challenging environment, embedding a rich cultural heritage directly into the geology of the continental rift. Perhaps the most astonishing testament to the escarpment's power is the treasure it has hidden and then revealed. The same geological forces that ripped the continents apart also created the conditions for one of the world's richest diamond deposits. Over eons, volcanoes deep within the earth carried diamonds to the surface in pipes of kimberlite. Then, the relentless erosion of the escarpment did the rest. Rivers flowing off the high plateau washed these diamonds downstream, eventually depositing them in vast, ancient beach terraces along the coast, now known as the Submerged, or Forbidden Territory. This diamond-rich zone was so valuable it was literally taken off the map for a century, its access strictly controlled. It stands as a direct, glittering result of the escarpment's erosive power, a billion-dollar treasure created by the same processes that carved the cliff face itself. Recognizing the incredible value of this entire ecosystem, geological, biological, and cultural, Namibia has become a world leader in conservation. Vast tracts of the escarpment and the coastal desert are now protected within national parks like the Namibian, one of the largest in Africa. Conservation models here are pioneering, often focusing on community-based tourism that gives local people a direct stake in protecting their heritage. This ensures that the story of the Namibian escarpment, from its tectonic birth and its unique life to its ancient human art and its hidden diamonds, will be preserved not as a forgotten cliff, but as a living, protected monument to the dynamic forces that shape our world. This journey to the edge of Africa now carries us across the globe to a border of a very different character, one that is almost entirely submerged beneath the contested waters of the South China Sea, guarding the secrets of the ancient continent of Carthasia. Beneath the contested, turquoise waters of the South China Sea lies a landscape of incredible geological and historical significance, a submerged world that was once the dramatic edge of a forgotten continent. These are the cliffs of Carthasia, an ancient landmass that formed the core of what we now know as southern China and much of Southeast Asia. Long before tectonic forces caused this continental margin to sink beneath the waves, these formidable escarpments stood as a mighty coastline, a natural border between a thriving land and the deep ocean. Today, they exist in a perpetual blue twilight, a ghostly realm of underwater ridges, plateaus, and canyons that hold the secrets to a lost chapter in Earth's history, a chapter that is now at the heart of some of the world's most intense geopolitical disputes. Unveiling the secrets of this sunken border requires the most advanced technology modern science can offer. Geologists cannot simply dive down to examine these cliffs. They rely on seismic imaging, a process akin to giving the planet an ultrasound. By sending powerful sound waves through the water and into the seafloor, then meticulously analyzing the echoes that return, scientists can construct detailed, three-dimensional maps of the hidden geology miles beneath the surface. What these images reveal is a complex and violent past. The data shows clear evidence of extinct volcanic arcs, the remains of ancient islands that were smashed onto the continental edge during past collisions. It also maps out vast, deep sedimentary basins, thick piles of mud, sand, and organic material that accumulated over millions of years in the quiet waters off the coast of Carthasia. These basins are not just geological curiosities, they are the source of the region's immense resource wealth, holding within their layers the potential for vast reserves of oil and natural gas, the very prizes that make this underwater frontier so valuable and so contentious today. For thousands of years, long before anyone knew of the oil hidden below, this region was defined not by its geology but by its location as the world's most crucial maritime crossroads. The South China Sea was the aquatic equivalent of the Silk Road, a superhighway for cultural and commercial exchange between China, India, the Middle East, and beyond. The submerged cliffs and islands that dotted this seascape were both navigational landmarks and deadly hazards for the countless junks, dhows, and merchant vessels that plied these waters. The seafloor along these ancient cliffs is a vast underwater museum littered with the remains of history. Archaeologists have discovered ancient shipwrecks from every era, their hulls filled with exquisite Chinese porcelain, intricate gold work from Philippine kingdoms, and spices from the Indonesian archipelago. These silent wrecks are time capsules, offering breathtaking snapshots of the vibrant trade that flowed across this sea for millennia, all passing by the enduring stone sentinels of the Carthaginian cliffs. This rich history of exchange and connection stands in stark contrast to the modern reality of the South China Sea, where the very same geological features that guided ancient traders are now the focal points of intense international tension. Those submerged cliffs, plateaus, and reefs have become the actors in a high-stakes geopolitical drama. Nations surrounding the sea lay claim to these features based on historical presence and the United Nations Convention on the Law of the Sea, which grants economic control over the waters and seabed resources for hundreds of miles around a territory. This has turned obscure geographical names like the Paracel Islands, the Spratly Islands, and the Scarborough Shoal into household terms synonymous with military build-ups, artificial island construction, and diplomatic standoffs. The conversation has shifted from one of shared cultural heritage to one of sovereignty, security, and control over the valuable energy reserves that the cliffs of Carthasia help to create and trap deep under the ocean floor. This forgotten continental border, hidden for eons, has been thrust into the spotlight, its geological past now inextricably linked to the political and economic future of the entire Asia-Pacific region. Venturing into the most remote and unforgiving wilderness on the North American continent, we find ourselves in the Canadian Arctic archipelago, a frozen world of stark beauty and profound isolation. Here, the Inuit Mountains rise like the jagged teeth of the earth, a formidable range that remains one of the least explored places on the planet. These are not mountains in the gentle, forested sense. They are raw, elemental cliffs of rock and ice, colossal fortresses that stand guard over the top of the world. These remote formations were once the dramatic northern coastline of the ancient continent of Laurentia, the primordial core of North America. For millions of years, this mighty cliff face was the continent's final frontier, a sheer wall plunging into the churning waters of the ancient Iapetus Ocean. It was a border between the solid, known world and a vast, mysterious sea that would one day close, only to be replaced by the even vaster Arctic Ocean we know today. To stand before these cliffs is to stand at the very edge of ancient Earth, a place where time feels measured in the slow grind of continents and the relentless advance of ice. The rock that forms these imposing cliffs is a time capsule from a period long before dinosaurs ever walked the Earth. We are talking about the Ordovician period, nearly 450 million years ago, when the planet's continents wore entirely different shapes and life existed almost exclusively in the seas. The Inuit cliffs preserve this ancient marine world in stunning detail. Fossil hunters brave enough to mount an expedition to this remote corner of the globe are rewarded with breathtaking finds. The limestone and shale layers are packed with the preserved remains of trilobites, brachiopods, and crinoid creatures that thrived in the warm, shallow seas that lapped against this ancient Laurentian coast. But perhaps the most significant finds are the remnants of nautiloids, early, squid-like creatures with long, conical shells. These fossils are not just beautiful curiosities, they are critical index fossils. Because these species evolved and went extinct rapidly, their presence allows geologists to pinpoint the age of these rock layers with remarkable precision, correlating this remote Arctic cliff face with similar formations in Scotland and Greenland, proving they were all part of the same ancient continental margin. The landscape surrounding these cliffs has been utterly dominated by one force for the last 2.5 million years: ice. The Inuitians are a pristine museum of glacial processes, a place where the power of ice to sculpt a continent is displayed on a monumental scale. The entire region has been repeatedly buried under colossal ice sheets that have planed down peaks, carved deep U-shaped valleys, and scraped the bedrock clean. As these continental glaciers finally began their retreat some 10,000 years ago, they left behind a dramatic and fresh glacial landscape. Everywhere you look, the evidence is clear and unmistakable. You can see immense cirques, the bowl-shaped hollows carved out at the heads of valleys by mountain glaciers. The cliffs themselves are often scarred with glacial striations, those parallel scratches etched into the rock by debris dragged along at the base of the moving ice. And scattered across the valleys below are endless erratic large boulders that were plucked from one place and deposited miles away by the slow, inexorable flow of the glacier, lonely monuments to the ice that once covered everything. For the Inuit peoples who have inhabited the Arctic for thousands of years, these formidable cliffs were never empty or unknown. In a landscape that appears featureless and overwhelming to an outsider, the Inuitian mountains provided essential landmarks for navigation and survival. The Inuit did not see this as a harsh wasteland but as a homeland, and their rich oral histories and place names are deeply intertwined with the geography. Specific peaks and rock formations were used as critical points of reference for hunters tracking caribou migrations across the vast tundra or for families traveling between seasonal camps. These places often carry names that describe their appearance or recount a story that happened there. Beyond their practical use, the cliffs and mountains also hold a deep spiritual significance in Inuit cosmology. They are often seen as the dwelling places of powerful spirits, or as the physical manifestations of ancient beings from the time of creation. This profound cultural mapping transforms the geology from mere rock into a living, storied landscape, a testament to human resilience and adaptation in one of the most challenging environments on Earth. Today, the very ice that has preserved and sculpted this ancient border is now retreating at an alarming rate, acting as a reluctant key to unlocking new secrets. Climate change is warming the Arctic at a pace nearly 4 times the global average, causing the region's glaciers and ice caps to melt at an accelerating rate. While this represents an ecological crisis of the highest order, it is also revealing patches of ground and rock faces that have been hidden under ice for millennia. For geologists, this is an unprecedented opportunity. Each summer's melt exposes new fossil sites, previously buried glacial deposits, and fresh rock exposures that provide a clearer picture of the mountain's structure and history. Scientists are now able to access and study areas that were utterly inaccessible just a few decades ago, gathering crucial data on past climate conditions and glacial dynamics. This research is doubly vital, as it not only helps us understand the deep past but also provides critical clues for predicting how the rapidly changing Arctic will impact the rest of the globe in the future. Rising from the dusty plains of Pakistan and northern India, the cliffs along the Indus Suture Zone tell a story not of a continent's edge, but of its dramatic and final embrace. This is not a border of separation, but of colossal, earth-shattering union. These rugged formations mark one of the most significant geological events in our planet's recent history, the moment the Indian subcontinent, after its 60-million-year solo journey across the Tethys Ocean, finally slammed into the underbelly of Eurasia. The cliffs are the visible scar of that impact, the suture line where two worlds were literally stitched together by unimaginable force, an event that is still actively pushing the Himalayas skyward today. To stand before these rock faces is to stand at the crumpled front line of the world's greatest ongoing continental collision. The most astonishing evidence of this transformation is found in the seemingly out-of-place geology of the region, particularly in Pakistan's Salt Range. Here, nestled within the foothills of the mighty Himalayas, you can find massive deposits of rock salt and gypsum, minerals known as evaporites that typically form at the bottom of shallow, sun-baked seas. Even more telling are the countless marine fossils, shells of ancient clams, imprints of sea lilies, and the remains of other ocean-dwelling creatures embedded in the limestone layers high up on the mountain slopes. This is the ultimate geological paradox, the undeniable evidence of an ancient seafloor now perched thousands of meters above sea level. These cliffs were once the bottom of the Tethys Ocean, a vast body of water that completely vanished, crushed, and uplifted between the converging titans of India and Asia. The rocks themselves are a perfect archive, preserving the entire history from a calm seafloor to the violent, grinding collision that ended it. This dynamic geology has profoundly shaped human destiny in the region for millennia, creating a landscape of both abundance and immense challenge. The same tectonic forces that raised the mountains also concentrated vital mineral resources. The salt deposits of the Salt Range have been mined for thousands of years, providing a crucial commodity for preservation and trade since the time of the ancient Indus Valley civilization. Cities like Harappa and Mohenjo-Daro likely benefited from this nearby resource. Conversely, the ongoing tectonic activity makes this one of the most seismically volatile regions on Earth. The same faults that mark the suture zone are capable of generating catastrophic earthquakes, as witnessed in the devastating 2005 Kashmir quake. The geology that provides life-sustaining minerals and fertile river valleys carved by the uplift also holds the potential for sudden, terrible destruction, a duality that has shaped settlement patterns and cultural resilience for centuries. The cultural tapestry of the region is deeply woven into this dramatic geology. The Indus River itself, from which the suture gets its name, is the lifeblood of Pakistan, and its course is dictated by the tectonic structures created by the collision. For the ancient civilizations that flourished along its banks, the towering mountains to the north were both a physical boundary and a source of myth and spiritual inspiration, often considered the abode of gods and sages. In more recent history, the rugged, impassable nature of these cliffs and the mountains they support have played a strategic role in conflict, influencing the movement of armies and acting as a natural barrier during periods of war. The land itself, forged by continental collision, continues to influence politics, culture, and daily life, a constant reminder that human history is often a footnote in a much deeper geological story. Today, the Indus Suture Zone is a living laboratory, a place where geologists from around the world come to study the mechanics of plate tectonics up close. By meticulously mapping the faults, analyzing the deformed rock layers, and monitoring the constant seismic rumblings, scientists can create models to better understand how continents behave during these slow-motion collisions. This research is critically important as it helps seismologists assess the earthquake risk for the millions of people who live in the shadow of the Himalayas. Every tremor and shift along this ancient wound provides new data, helping to predict where and when the next great quake might strike. The cliffs of the Indus Suture are not a static relic. They are a dynamic, active, and crucial feature for understanding the forces that continue to shape our planet, offering vital lessons written in stone and seismic energy. Venturing into the frigid expanse of the East Siberian Sea, we encounter a landscape that feels like the very end of the world, the New Siberian Islands. This remote and desolate archipelago, shrouded in ice and fog for much of the year, is home to some of the most revealing and rapidly changing cliffs on the planet. These formidable exposures of rock and permafrost are not merely remote geological features. They are the crumbling, northernmost edge of the ancient Siberian Craton, one of the oldest and most stable pieces of continental crust on Earth. For billions of years, this cliff line has stood as a silent sentinel, facing the Arctic Ocean and enduring countless cycles of ice ages and warming periods. Today, these frozen bluffs are acting like a vault that is suddenly cracking open, offering an unparalleled glimpse into a lost Arctic world of staggering biodiversity and dramatic climate shifts, a world we are only just beginning to understand as it literally thaws before our eyes. The most breathtaking discoveries emerging from these cliffs are the countless remains of Pleistocene megafauna, perfectly preserved in the deep freeze of the permafrost. As the frozen ground thaws and erosion wears away at the cliff faces, paleontologists are recovering an astonishing array of specimens. We are talking about entire carcasses of woolly mammoths with their fur, skin, and muscle tissue still intact, their stomachs often containing their last meals of grasses and flowers. They find woolly rhinoceroses, cave lions, and even startlingly complete specimens of the extinct steppe bison. But it is not just the animals. The cliffs also contain the frozen remains of the world they lived in. Scientists have uncovered vast, frozen peat bogs and the stumps of ancient forests, with trees that were suddenly engulfed and flash frozen by shifting sediments and plummeting temperatures. This is not a scattered bone here and there. This is an entire ecosystem, snap frozen in time and now being defrosted by a warming climate, providing an unprecedented level of detail about the Arctic's lush past. This rich biological record tells a powerful story of a climate that was once very different. During the last ice age, this region was not a barren wasteland but a vast, grassy plain known as the Mammoth Steppe. This incredibly productive ecosystem stretched from modern-day Spain all the way across the Bering Land Bridge into Canada, and it was able to support a tremendous biomass of large grazing animals. The New Siberian Islands were not islands at that time. They were high points within this sweeping steppe, connected to the mainland by the exposed continental shelf. The fossils and preserved vegetation tell us this environment was cold but relatively dry, supporting a rich carpet of grasses, herbs, and willow shrubs that sustained the great mammoth herds. The cliffs, therefore, hold the evidence that challenges our very notion of the Arctic, revealing it was once a thriving, wildlife-rich savanna at the top of the world. For the indigenous Yakut people who have inhabited the surrounding Siberian mainland for centuries, these remote islands have always held a profound significance that transcends Western scientific inquiry. In the rich oral traditions and shamanic beliefs of the Yakuts, the New Siberian Islands are not random lumps of rock and ice. They are a mystical and deeply spiritual realm. They are often considered the entrance to the underworld, a place where spirits reside and the boundaries between the human world and the unseen world are thin. The incredible preservation of the animals within the permafrost features in their legends. Some stories speak of giant creatures that long ago retreated beneath the earth to escape a changing world, and whose occasional uncovering is a message or an omen. This cultural interpretation offers a fascinating counterpoint to the scientific one, viewing the cliffs not as a databank for research, but as a sacred, animate landscape with its own agency and meaning. The urgent scientific race underway on these islands is driven by a paradoxical and sobering reality. The very process that is revealing these treasures, climate change, is also ensuring they will be lost forever if not recovered quickly. As the Arctic warms at more than twice the global average rate, the permafrost that has acted as a natural deep freeze for tens of thousands of years is thawing at an accelerating pace. When these frozen specimens are exposed to air and microbes, they decompose with shocking speed, turning to mush and being lost to science within a single season. This has triggered a frantic effort by paleontologists and geneticists to mount expeditions to these remote cliffs, racing against the elements to recover specimens before they rot away. Their work is yielding more than just museum exhibits. The recovered DNA is providing revolutionary insights into the genetics of extinct species, and even fueling controversial de-extinction projects aimed at potentially bringing animals like the woolly mammoth back to life. Beyond the spectacular fossils, the layered sediments within these cliffs provide a continuous, million-year-long geological diary of Arctic climate change. By studying the composition of the mud, the types of pollen grains, and the isotopes locked within the ice, scientists can reconstruct a detailed history of temperature fluctuations, atmospheric composition, and sea level rise and fall. Each layer in the cliff face is a time capsule, recording what the environment was like when it was deposited. This long-term perspective is absolutely vital for climate scientists today, as it provides the essential baseline for understanding natural climate variability. It allows them to distinguish between natural cycles and the unprecedented, human-caused warming we are now experiencing, helping to refine the models that predict our planet's future. The New Siberian Islands, in their frozen silence, are therefore contributing critical data to one of the most pressing issues of our time, their cliffs serving as both a memorial to a lost world and a warning for our own. Shifting our focus from the frozen vaults of the Arctic, we arrive at a place where continental separation is not a frozen event of the deep past, but a vibrant, ongoing spectacle happening right before our eyes. This is the Red Sea Rift, a landscape of stark, dramatic beauty where the very earth is tearing itself apart. The colossal cliffs that line the coasts of Saudi Arabia and Egypt are not static monuments. They are the raw, freshly exposed edges of two massive tectonic plates, the African and Arabian, caught in the act of a slow-motion divorce. This is one of the youngest and most active rift systems on the planet, a place where you can literally witness the birth of an ocean. The immense escarpments of the Hijaz and Sarawat Mountains are the fault scarps of this planetary-scale event, a crumbling wall that marks the exact point where the Arabian Peninsula began to pull away from Africa some 25 million years ago, a process that continues to this day, inexorably widening the Red Sea millimeter by millimeter every year. This geological drama has created a treasure trove of mineral wealth that has drawn humans to these harsh cliffs since the dawn of civilization. The same titanic forces that fractured the continent also heated the deep crust, circulating mineral-rich fluids that deposited vast veins of gold and copper into the faults and fractures of the newly formed rift valleys. This subterranean bounty did not remain hidden for long. The ancient Egyptians were among the first to systematically mine this wealth, sending expeditions into the eastern desert of Egypt and the mountains of the Sinai Peninsula over 5,000 years ago to extract the gold that would adorn the tombs of pharaohs and fuel their economy. They were followed centuries later by the Nabateans, the brilliant engineers who built the rock-cut city of Petra. The Nabateans mastered the extraction of not only gold but also copper, and they controlled the lucrative trade routes that carried these precious metals north to the Mediterranean world. The very geology of the rift cliffs provided the resources that built empires and financed cultures, etching a human story directly into the mineralized bones of the continent. The influence of this rifting extends far beyond the cliffs themselves, fundamentally shaping the geography and economy of the entire modern region. The Red Sea itself is the direct result of this tectonic rupture, a long, narrow, and incredibly deep oceanic basin that now separates two continents. This unique geography has made it one of the most vital shipping corridors in the world, the quickest maritime link between Europe and Asia via the Suez Canal. Every day, a significant portion of global trade, including massive tankers carrying oil from the Persian Gulf, navigates these waters. The geology of the rift is also directly tied to that oil wealth. The same tectonic processes that created the Red Sea also formed the perfect geological conditions to trap vast reserves of oil and natural gas in the surrounding sedimentary basins. From the ancient mines of pharaohs to the modern tankers and oil rigs, the economy of the region is a direct legacy of the forces that created these cliffs. Despite its ancient human history, this remains a landscape dominated by powerful and relentless natural forces. The Red Sea Rift is seismically active, with frequent small earthquakes reminding everyone that the continental plates are still very much in motion. The climate is brutally arid, with some of the hottest and driest conditions on Earth. Here, the primary artist shaping the cliffs is not rain or ice, but wind. The relentless abrasive action of sandblasting winds has sculpted the sandstone cliffs into surreal, intricate formations, delicate arches, deep alcoves, and soaring pinnacles that seem more like a work of abstract art than a natural landscape. This wind-carved terrain, combined with the volcanic fields of black basalt that dot the region from ancient eruptions along the rift, creates a vista of almost otherworldly beauty, a stark and magnificent testament to the powerful, non-stop forces of geological change. For scientists, the Red Sea Rift is a priceless natural laboratory, offering a unique opportunity to study the very earliest stages of a process that will, over tens of millions of years, eventually create a vast new ocean. By monitoring the gradual spreading of the seafloor with satellite-based GPS technology, they can measure the precise rate of continental separation, which is about 1 centimeter per year in the north and nearly double that in the south. They study the unique hydrothermal vent systems on the deep seafloor, where superheated, mineral-rich water supports bizarre ecosystems that thrive without sunlight, offering clues about the very origins of life on Earth. This ongoing research provides a crucial model for understanding how all ocean basins form and evolve, making these sun-baked cliffs a key to understanding the most fundamental processes that shape our planet's surface. This living, breathing border of the Red Sea perfectly sets the stage for our next destination, a cliff that witnessed a similar continental divorce but met a completely different fate, submerged beneath the waves of the Indian Ocean off the coast of ancient Australia. Far to the west of Australia, hidden beneath the rolling swells of the Indian Ocean, lies a sunken landscape that holds the secrets to a monumental continental breakup. This is the Naturaliste Plateau, a vast, submerged fragment of continental crust whose most dramatic features are its immense underwater cliffs. These are not mere slopes, they are the crumbling, drowned edges of a border that once connected two worlds. Over 130 million years ago, this was not the deep, dark abyss it is today. It was a shallow sea, a continental shelf that formed the very last land bridge between Australia and Antarctica. The cliffs of the Naturaliste Plateau were the final sentinels of that connection, the last high ground watching over the rift valley that would, in a geological instant, tear the supercontinent Gondwana in two and begin the opening of an entire ocean. Uncovering the history of this completely submerged border requires a form of geological remote sensing, using sound waves to paint a picture of a world no human eye can see. Oceanographic research vessels tirelessly crisscross this region, deploying multi-beam sonar systems that create stunningly detailed, three-dimensional maps of the seafloor. These maps reveal the ghostly contours of the plateau's cliffs, ancient river valleys that now sit a mile underwater, and deep canyons that slice through the old continental margin. But to truly read the story locked in the rock, scientists must go further. They use massive drills mounted on specialized ships to extract core samples from deep within the seabed. These long cylinders of mud and rock are time machines. As geologists analyze the layers, they find a clear and powerful narrative. At the bottom of the core, there are basaltic rocks from the volcanic eruptions that accompanied the initial rifting. Above that, layers of shallow water limestone filled with fossils of creatures that lived in a warm, sunlit sea. And at the very top, layers of deep ocean clay, silently marking the moment the land finally sank beneath the waves for good, and the Indian Ocean was born. This forgotten cliff does more than just record ancient history. It actively shapes the present-day ocean in profound ways. The immense topography of the plateau, with its steep slopes and deep canyons, acts like a massive obstacle on the seafloor, disrupting the flow of powerful deep water currents. As these currents are forced up and over the plateau, they create massive upwellings, pulling nutrient-rich waters from the abyssal depths up toward the sunlit surface. This process fertilizes the ocean, triggering vast blooms of phytoplankton that form the base of an incredibly rich and unique marine food web. The cliffs and canyons themselves provide a solid foundation for life in the soft, muddy desert of the deep sea. Their rocky faces are encrusted with deep water corals, sponges, and anemones, which in turn create complex habitats for a bizarre and wonderful array of fish, crustaceans, and other deep-sea denizens. This thriving ecosystem, hidden in perpetual darkness, exists only because of the geology of that ancient continental border. The research conducted here reaches far beyond mapping a lost world. By studying the layers of sediment in the core samples, scientists can analyze ancient pollen and microorganisms called foraminifera. The types of species found and the chemical composition of their shells act as precise thermometers and rain gauges, recording detailed changes in Earth's past climate. These archives show us how climate patterns shifted as Australia drifted northward away from Antarctica, transforming the region from a temperate environment into the arid landscape we know today. Furthermore, the Naturaliste Plateau is a textbook example of a passive continental margin, and studying its structure helps geologists refine the entire theory of seafloor spreading and plate tectonics. By understanding how this cliff sank and how the ocean basin widened here, they can create better models for how all the world's oceans form and evolve, making this sunken frontier a crucial key to understanding the dynamic planet we call home. Journeying now from the sun-scorched rift valleys of the Red Sea, we arrive at a landscape that is the geological opposite of drama and change, a place of profound, ancient stillness. This is the East European Craton, a colossal, stable block of continental crust that forms the very foundation of much of northeastern Europe. Within it, in regions like the Baltic Shield of Scandinavia and the rocky outcrops of Ukraine, we find cliffs of a different character altogether. These are not the dramatic, freshly cut scarps of a young rift, nor the crumpled peaks of a recent collision. They are the worn, stoic, and almost unbelievably ancient sentinels of Earth's earliest history. These rock faces were the immutable core of the ancient continent of Baltica, a steadfast island of stability that for billions of years formed a resilient border against the churning chaos of vanished oceans like the Tornquist Sea. To stand before these cliffs is not to witness the violence of plate tectonics, but to feel the deep, silent endurance of a planet that has found its footing. The rock that comprises these formations is so old it defies easy comprehension. We are speaking of Precambrian bedrock, dating back to the Archean and Proterozoic eons, over 2.5 billion years in age. This is a time before complex life, before atmospheric oxygen, when the planet was a vastly different and more violent place. Unlike the layered sedimentary rocks that tell a story of ancient environments, the cliffs of the Craton are primarily composed of granite and gneiss rocks forged by unimaginable heat and pressure deep within the young Earth. Their value to science is incalculable because this crust has remained largely undisturbed by later tectonic events. It has avoided the recycling and melting that has erased so much of Earth's earliest history. These cliffs are a pristine page from the first chapter of the planet's geological diary, offering a direct window into the processes that formed the very first stable continents. Geologists study the intricate patterns within this metamorphic rock, reading the history of the immense forces that cooked and compressed it, understanding how these primordial landmasses coalesced from a molten world. This geological stability did more than just preserve rock. It created a predictable and resource-rich platform that has directly shaped human history for millennia. The same ancient geological processes that formed the Craton also concentrated immense mineral wealth within its bones. The region of the Baltic Shield, for instance, is extraordinarily rich in iron ore, a resource that became the economic engine for entire empires. This abundance directly fueled the Viking Age. The quality of steel they could forge from this native iron was a key technological advantage that enabled their expansion, trade, and raids across Europe and beyond. Later, these same deposits would form the backbone of Sweden's industrial revolution. In Ukraine, the stable cratonic foundation overlain by younger sedimentary layers created the conditions for vast deposits of coal and the fertile, black Chernozem soil that would make the region the agricultural breadbasket first of the Russian Empire and then the Soviet Union. The unyielding, ancient rock below literally supported the economies that flourished above it. The human story woven into this ancient landscape is one of trade, culture, and conflict, all influenced by the lay of the land. The rivers that drained the stable highlands of the Craton, such as the Dnieper in Ukraine and the Volga in Russia, became superhighways of commerce and migration. These waterways were the conduits for the legendary Varangians Viking traders who traveled from the Baltic Sea down to the Black Sea, connecting the Norse world with the Byzantine Empire. Their routes were dictated by the geology, following valleys carved over eons. Later, Slavic settlers built fortified towns and cities on the high bluffs of these rivers, using the natural defensive advantages provided by the old cliffs. The city of Kiev itself is famously built on such high riverbanks. Its historical significance and strategic power derived in no small part from the elevated, defensible geography provided by the underlying cratonic structure. The geology provided not just resources but security and routes for connection. In the modern era, the East European Craton has become a fascinating natural laboratory for a unique geological question, not how continents form but how they survive. While most of the planet's crust has been endlessly recycled, folded, and faulted by the relentless motion of plate tectonics, the East European craton has remained remarkably intact. Its secret seems to lie in its incredible thickness and rigidity. Over billions of years, it has become a cold, thick, and buoyant block, essentially acting as a geological unsinkable raft. When younger, more energetic tectonic events have occurred around its edges, the craton has simply resisted deformation, causing the forces to warp the weaker rocks around it instead. Modern studies use detailed seismic imaging to map the deep root of this craton, which extends hundreds of kilometers down into the mantle, understanding its composition and strength. This research is crucial because it helps explain why some continents have cores that persist for billions of years, forming the stable hearts around which the rest of the geological drama unfolds. This understanding of a border defined by its resolute immutability sets the stage for our final cliff, a submerged formation that tells the story of a continent that did not survive intact, but was instead torn in two. Far to the west of Ireland, beneath the stormy, grey waters of the North Atlantic, lies a submerged world that holds the final piece in our puzzle of forgotten borders, the Rockall Plateau. This vast, underwater mesa, with its dramatic cliffs hidden in the perpetual dark, is far more than a simple seabed feature. It is a ghostly monument to a time when Europe and North America were not separate continents divided by a vast ocean, but neighboring lands connected by a narrow thread of crust. The plateau's sheer escarpments are the last remnants of that land bridge, the crumbling edge of a continental margin that was stretched, heated, and finally torn asunder by the same titanic forces that would go on to forge the Atlantic Ocean we know today. This is the story of a border that didn't just separate two worlds, but whose very destruction created the ocean that now defines them. Unlocking the secrets of this sunken frontier is a task that demands technology capable of seeing through miles of water. Geologists cannot dive to these depths. Instead, they act as remote detectives, using advanced tools like multi-beam sonar and seismic reflection profiling to create stunningly detailed, three-dimensional maps of the seafloor. These technologies work by sending powerful sound waves down through the water column and into the rock below, then meticulously analyzing the echoes that return. What these sonic portraits reveal is a complex geological history written in stone. The data shows clear evidence of massive volcanic outpourings, layers of basalt that erupted as the continent first began to thin and crack under immense tectonic strain. It also maps out deep sedimentary basins, thick accumulations of sand and mud that filled the valleys of the nascent rift, preserving a perfect record of the environment as the land slowly sank beneath the waves. These underwater formations are the definitive proof that this was once dry land, a place where rivers once flowed across a landscape that now sits at the bottom of the ocean. This hidden geological wealth has placed the Rockall Plateau squarely at the center of a modern, high-stakes drama. The same sedimentary basins that tell the story of continental breakup are also believed to hold significant reserves of oil and natural gas trapped within their porous rocks. Furthermore, the nutrient-rich waters that upwell around the plateau's edges support some of the most productive fishing grounds in the North Atlantic, making these international waters a vital economic zone. This potent combination of potential energy and existing food resources has turned the region into a subject of intense territorial dispute. For decades, nations including the United Kingdom, Ireland, Iceland, and Denmark have jockeyed for control, laying claim to sectors of the plateau based on interpretations of continental shelf extensions under the United Nations Convention on the Law of the Sea. The tiny, barren islet of Rockall itself, a mere speck of rock that is the plateau's only point above water, has been the focus of symbolic flag planting and even military occupation, a stark reminder of how the ghosts of ancient geography can ignite modern conflicts. Beyond the politics and economics, the Rockall Plateau serves a higher scientific purpose, acting as a crucial piece in the grand jigsaw puzzle of the North Atlantic. By studying the precise structure of its volcanic rocks and the age of the sediments in its basins, geologists can precisely reconstruct the sequence of events that led to the final separation of the European and North American plates. This research helps them pinpoint the timing and direction of the rift, understanding how it propagated northward from the central Atlantic to finally open the sea between Greenland and Europe. Each core sample extracted from the seabed, each seismic profile completed, adds another data point to our understanding of continental drift, helping to refine the models that explain how our planet's surface has evolved over the last 200 million years. The plateau is a missing link, a key that helps us understand the complete story of the Atlantic's birth, from the rupture of Pangea to the formation of the ocean we see on our maps today. What becomes truly fascinating as we step back from these 27 individual stories is the emergence of powerful, unifying themes that connect these forgotten cliffs across billions of years and thousands of miles. Despite their vastly different locations and origins, they all share a profound role as Earth's ultimate architects, silently directing the flow of life, resources, and human destiny through deep time. Perhaps their most universal function was as grand dividers and connectors. These colossal cliffs acted as planet-scale filters. For biology, they were both barriers that created isolated laboratories for evolution and bridges that allowed for the great exchange of species. The Wallace Line is the most stunning example, where a deep ocean trench created entirely separate biological universes on neighboring islands, but we see this echoed everywhere. The western Ghats of India, isolated for millennia after its break from Madagascar, became a cradle for species found nowhere else on Earth, while the Bering land bridges exposed plains served as a migratory superhighway, funneling mammoths, bison, and the first people into the Americas. This same dynamic played out for humanity. The great escarpments, like the Serra do Mar in Brazil or the Tel Atlas in North Africa, provided natural fortifications that protected developing cultures, while the passes that cut through them, like those in the Urals or the Appalachians, became the strategic choke points that guided trade, conquest, and the spread of ideas, literally shaping the map of human civilization. Furthermore, these borders are almost always treasure troves of concentrated wealth, a direct result of the immense geological forces that forged them. The violent collisions that built mountains like the Urals or the Wachitas cooked the Earth's crust, creating rich veins of gold, copper, platinum, and diamonds. The slow erosion of these same cliffs then washed these minerals downstream, depositing them in alluvial plains or on ancient beaches, as seen in the diamond-rich sands off the Namibian Escarpment. But the wealth isn't just metallic. The fertile soil that collects at the base of these slopes, nourished by minerals washed down from above, often created the first agricultural heartlands for human settlers. And in the modern era, the sedimentary basins formed by the rifting and stretching of continents, as with the Rockall Plateau or the South China Sea, became the perfect traps for the fossilized energy of ancient life, oil and natural gas, making these forgotten borders the unexpected epicenters of global economic and political power struggles today. Yet, for all their monumental permanence, a central paradox defines these cliffs: their obscurity. The very forces that raised them are the same ones that inevitably hide them from view. The mighty Caledonian cliffs, once Himalayan in scale, have been ground down by ice and rain into the soft green hills of Scotland. The dramatic edge of the Bering land bridge now lies beneath 50 meters of chilly ocean water, its story only accessible through sonar and sediment cores. The pristine cliffs of the Guiana Shield remained hidden for eons by the dense Amazon rainforest, their tabletop summits becoming isolated worlds, and in countless other places, human activity has completed the work of erosion with terraced agriculture, mining operations, and urban sprawl softening the raw, dramatic profiles these borders once held. Their forgotten nature isn't an accident. It is the inevitable result of a planet that is never at rest, constantly reshaping its own surface. This is precisely why they are so invaluable to science. By comparing these 27 cases, geologists can discern the fundamental patterns of how continents behave. They are the key to understanding the entire supercontinent cycle, the repeated assembly and breakup of Earth's landmasses. The scars of old collisions, like the Appalachian Wachita chain, show us what the ongoing crash in the Himalayas will look like in 200 million years. The young, active rifting of the Red Sea gives us a model for how the Atlantic Ocean first began to open. By studying these ruins, we learn to read the language of the planet itself, allowing us to not only reconstruct the past with astonishing accuracy, but also to model the geological future, predicting how our world might continue to change long after we are gone. These forgotten cliffs are therefore much more than historical curiosities. They are active textbooks offering crucial lessons on resilience, change, and the deep interconnectedness of the physical world that continues to support and shape our human story. Our journey across the planet, from the icy sentinels of the Scans to the sunken secrets of the Rockall Plateau, reveals a truth far grander than any single cliff, that the Earth itself is a living, breathing chronicle of change. These 27 forgotten borders are not isolated wonders. They are individual verses in an epic poem written in stone, each narrating a chapter of colossal continental collisions, slow-motion divorces, and the relentless, sculpting hands of ice and water. They teach us that the ground beneath our feet is not a static stage but a dynamic participant in the story of life, a force that has directed the evolution of species, guided the migration of early humans, and provided the very resources that fueled the rise of civilizations. The fjords of Norway, the diamond sands of Namibia, the spiritual peaks of the Guiana Shield, each is a permanent echo of a border that once was, a ghost in the landscape that continues to whisper its influence into our modern world. This deep time perspective is not merely an academic exercise. It is a crucial lens through which to view our present and future. As we confront unprecedented global challenges like climate change, the lessons etched into these cliffs become more vital than ever. They are masterclasses in resilience and adaptation, showing us how life persevered through ice ages and how continents recovered from cataclysmic ruptures. The ancient rocks of the East European Craton demonstrate the power of stability, while the violent birth of the Himalayas reminds us of the planet's incredible capacity for transformation. Understanding these cycles of destruction and rebirth fosters a profound respect for the intricate systems that sustain our world, encouraging a more thoughtful approach to how we manage its resources and protect its fragile environments. These geological wonders are a testament to the fact that change is the only constant, and our ability to adapt, much like the species that crossed the Bering Land Bridge, will define our own chapter in Earth's long history. This exploration is a powerful reminder that our maps are temporary and the borders we draw are fleeting. The cliffs that once divided continents are now worn smooth, submerged, or buried, their stories waiting to be deciphered by those who know how to look. It invites us to see the world with new eyes, to look at a rolling hill and imagine the Himalayan scale peak it once was, or to gaze at a calm ocean and envision the lost landscapes lying beneath the waves. This spirit of curiosity is what drives discovery, and it's a spirit I hope this journey has ignited in you. I would love to hear which of these forgotten cliffs captured your imagination the most. Was it the biological rift of the Wallace Line, the human drama woven into the Tell Atlas, or the frozen mysteries of the New Siberian Islands? Share your thoughts in the comments below, and if you enjoyed this dive into the planet's deepest secrets, please subscribe and hit the notification bell so you don't miss our next exploration into the world's great historical mysteries. Thank you for joining me on this incredible trek through time. Keep asking questions, stay curious, and never stop exploring.